Canvas Training. Learn and grow.
So this is session 1, Introduction to Cloud Computing. And today's expectation for this class is this. So we're going to understand what cloud computing is, what are its advantages, what are different models of cloud computing, what are deployment models, what cloud computing services are out there. Then we will just dip our toes into AWS, what it is, how it got started, why AWS, why each and every company is stepping on AWS, and what is its market share, why AWS is a leader. So what is cloud computing? So it's not like there's some cloud or there is some, Fugazi thing from where you are getting your compute power. Cloud is anything that you can reference, that you have out there somewhere. You really don't know where it is, because when you see a cloud, you really don't know how high it is unless and until you have real measuring equipment. And it's just someone else's computer. There is no cloud. So how the cloud computing model came into existence. So let me take you to a brief history of cloud computing. So initially what happened that, say, there were few big internet giants, for example, Amazon, running tens and thousands of servers. And you have your Google, you have your Microsoft, you have your Yahoo, you have your Facebook. So these people have to plan for worst case scenarios. And by worst case scenarios, I mean, say there is a Black Friday sale. Amazon has to prepare for that in advance, right? If they go out shopping for computers on the Black Friday market, they are not going to able to serve those orders, that huge amount of traffic. Similarly, Google. So say thousands of people just come online and start checking their Gmail, start doing Google searches, and that number starts growing as the day progresses to maybe a million, 10 million, billion, because these services have billions of users. Take Android, for example. There are over 1.5 billion users of Android right now. It's almost touching 2 billion active users at this moment of time. And to serve that huge amount of traffic, you need to have the capacity. And that capacity doesn't always remain at the peak. So say, I'll take example of Black Friday sale. So say on Black Friday, average 500 people shop. Those 500 people are not going to shop all 365 days of the year. You get me? They are maybe 10 or 20 login daily, but on Black Friday sale to grab those deals, all 500 login. So they have to have the capacity to handle those 500 users on the Black Friday sale, right? So 500 is really a small number. What I'll be saying 5 million or 5 billion or 50 million users. So to cater that 50 million user traffic, they have to have capacity there. Apart from Black Friday, all 364 days of the year, that capacity is sitting there ideal. They're not using it because there isn't that much of interest in their site. Maybe 1 or 2 days, maybe on Christmas, maybe around the holidays, maybe somewhere around 4th of July. But they won't be having that much traffic all throughout the year, maybe selected 10 or 15 days. So to really use that capacity, rest of the 360 days of the year, what they did, they started renting out their capacity. Okay, I have servers. I'm not using them right now. I will need them till, I won't need them till Black Friday. Why don't you take these on rent? I'll provide you a connection to it and you can use that. And that's how cloud computing model came into existence. Huge companies having huge amount of capacity and nowhere to use it, started renting them out, and cloud computing was born. So the first company that started this on a really massive scale was AWS, and that's why it's a market leader right now. So we'll go more into that. Let me jump back to my slides. So cloud computing, on-demand delivery, whichever company needs that capacity, they just have to, okay, you have this much extra capacity, I want, say, 20 servers on the rent, you get that. You have database, you have storage, you have compute power, and other IT resources like internet, like network, you have redundancy, you have multiple servers, all available to you. So you get on-demand delivery of your compute resources, you get whenever you want. So say I'm a startup, right? I have a huge VC pitch today. Maybe I'm running a Super Bowl ad and I expect huge amount of traffic. What I do, I go to AWS. Okay, I'm expecting huge amount of traffic. Can I take 30 servers on rent? So it's just pay as you go. It's just rental. So you just go out there and just just give a few servers on rent and they'll give that to you. And it provides a really simple way, because earlier in the day, if you want an internet company, either you have to set up your own data center, you have to look for land, you have to build a huge building, you have to put air conditioning in for all those servers, you have to install server, you have to have hundreds of administrators managing that data center for you, and then you have to make sure that it stays alive. You have to have multiple power connections, you have to have backup generators, and each and everything used to add up a lot of cost. Now with cloud computing, all that is taken care of, and you can directly use that compute, that network. Because my target is not building a data center, my target is actually using that compute capacity, right? So if I'm a startup, say I'm just growing, I don't need to have a whole data center. But yes, now you can. Earlier in the days, you couldn't, because you have to had your own data center, or you had to rent space in somebody else's data center. But now you can just go out there overnight, you can build your idea and launch it to whole world, because cloud computing provides that, right? So cloud computing providers like AWS, there is Google Cloud Platform, there is Microsoft Azure, there is Alibaba Cloud, there is Oracle Cloud, there is IBM Bluemix Cloud. So each and every big wigs are stepping in cloud game, but they are a little bit too late, I would say, because AWS controls around 50% of the market. That's why it is the right choice of a cloud provider, whether you are learning or you are implementing something. Say you are a startup, you want to grow, you have to go where the market is heading, because if market is heading there, it must have something good. 50% of the cloud market, these are big industries, big companies. They don't invest their money on any product, they want best of best, and AWS is indeed best of best that is out there. And because they started first, they have an advantage as well, because these things take time to set up, right? AWS started first, they have that advantage. So cloud computing is here really, if you put it in simpler terms, rental service, right? You want something, you rent it for a few hours, you don't want it, you just shut it off. And that really gets you the saving. Say you are a company based out of maybe New York, and you want to build out a dashboard for all your employees, right? And dashboard has to have some compute power, some computer running, right? And your employees are in the office, say only 9 to 5. Now for the rest of the 16 hours, or maybe 15 hours, maybe 10 hours even, say some employees are extra hardworking, they work 14 hours a day, and for the rest of the 10 hours you don't need that dashboard, right? So what you can do, you can go to AWS, get a server for just 14 hours, you'll be charged just for 14 hours, and you'll save rest of the 10 hours of money. If you want to purchase your own server, you have to have that server in your backyard, in the company backyard, always running. You have to put upfront payment for it, buy it, and then hire a bunch of people to set it up, and then only you can get something out of it. So that's the basic of cloud computing, rental compute. So this is just what I explained. It's a utility service. You can access to your technology resource manage, always available on demand whenever you want to rent those house. No upfront cost. You only pay for what you use. It's like power. So say there is a power company and you have a connection, right? So connection in this case is just the internet. In case of power company, you have to have a wire running down to your house. Now you want to use, say, for the power for 10 days. You will be charged for that power for only 10 days, not the whole 30 days, only 10 days. That's how cloud computing is. You want a server for 5 days, take the server for 5 days. You will be charged for that only. You want something else for, say, you want storage, you want to store a 1 terabyte of data, 100 of GBs of data in the cloud, you can do that. So say you want to store that for a month. Yeah, no problem. Just pay for the month. Because there is a huge capacity out there, and there are so many people willing to take that capacity. It works for both the companies as well as the users. So advantages of cloud computing. As I've been explaining till now, cloud computing is really on demand rental kind of model. So instead of having to invest in your own data centers, as I explained before, what you get a fully functional data center, directly connection into that, your own server spinning on the internet within maybe 5 clicks. And as we go along this course, maybe in 2 weeks, you will be able to spin up your own servers, connect it via your own phone, set up your own websites for yourself, for your clients, and for the prospective companies you are going to work for. So cloud computing is really going to put power in your hands, because many candidates often ask me, what I am just doing is just taking some rental service. Why would company want to pay me such huge amounts? Because nobody knows really how to use that rental service. A service is as good as its users, and if you are a great user, you can extract great value out of that service, right? So when you are saving company money, when you're saving a company a lot of money, companies will pay you a small fee. Simply a very economic world out there. You do something good for me, I'll do something good for you. That's how they usually work. And you get advantages from massive economies of scale, because Amazon has, say, million servers. They're using maybe 715,000 of those. They have 250,000 servers available with them, not getting used. They're putting them out for rent, and you can tap that power, avail them for cheap without having to jump all the hoops of setting your own data center, hiring people to manage that data center. So in earlier days, you had to have a whole building management and facilities team just to maintain that data center, and you're not getting any value out of it. The value is in the IT resources that are there inside the data center, not in the data center building. That data center building can be converted into a warehouse. It can be converted into a normal storage house. The actual value is the stuff that is running in there. And if you get that stuff elsewhere for cheap without having to jump through all the hoops, it's better. So stop guessing capacity. Now, let me take you into a scenario, right? So you are an IT engineer, right? So you developed something, you have a really good application, really great Android application, really great iPhone application, and you put it out there, right? So this actually happened with a couple of applications. I'll tell you the example. So there is an app called Pokemon Go, where you could go around the city catching Pokemons, and they were not expecting that it will pick up so fast. And what happened overnight, over million people started using that application. Now imagine sitting in their IT and taking hits of a million people. You have to serve a million peoples, right? Say they were in a traditional data center, what would have happened? Their data center is small, they cannot really expand the building overnight. First failure. Second failure, they have to buy the servers. Servers don't come cheap. You cannot get that much capacity upfront. And even if you get that, it is hard to set up those servers. They are going to fail and everything. And all this will take huge amounts of time. And if the site is down for even 5 minutes, maybe an hour, maybe a day, 80% of people won't come back to that site, because you are not healthcare services, you are not 911, you're not a stock market that people will come flocking for you. You are a business, you have to be competitive out there. And if you are not competitive, if you are not up, your opponents, your competition is going to have an edge, and you are not going to be that edge. You're going to lose customer, you're going to lose money. So with cloud computing, you get hundreds of data centers around the world just at a click of a button. So even if, say, God forbid, a whole region is down, say whole continent is cut off from the power supply, you have 4 other continents to go to set up their compute power, and you can serve users from rest of the world. So with cloud computing, you get speed, you get agility, you get capacity, because you're not going to scale up to Amazon scales overnight. Let's be clear about that. But yes, you can scale to Amazon in early days, and that capacity is there in AWS. Tap that, pay after a month. After a month, your ad revenues have come in, pay it. It's just like a rental, and you are on your way. So this is what I've been telling. Stop spending money on running and maintaining data centers, because you don't want to run and maintain a building. What you want is actually that compute power, and you want to have the agility to go global in seconds. So that's what you get here. So In cloud computing, there are basically three models. So I'll explain each one of these in detail, and it's very important. All right. So there are three models in cloud computing. One is IaaS, that is infrastructure as a service. Then there is PaaS, platform as a service, and there is SaaS, software as a service. Now, to get a layman's view about what these are, IaaS is actually like having your own server. So, say you go there in a store and buy a computer. IaaS is only like that, except you don't have a physical access to that computer, you have virtual access to that computer. You get the storage, you get the capacity, you get the compute and everything. But yes, your access will be virtual, and that will be sitting in some data center owned by Amazon. So IaaS is like buying your own computer, but because in cloud computing you're taking everything as a rent, so that computer is somewhere out there in Amazon's huge data center, and you are just connecting it over the internet and using it, configuring it to whatever purpose you want. Then you have PaaS, platform as a service. So platform as a service is like Google Maps. So Google Maps is a platform for you. So you use Uber, right? So whenever you are requesting a ride, the Uber shows you your starting position and your end position and all the drivers that are around you on a Google Maps, right? So Uber is using Google Maps platform as a service to provide you the cab locations, to provide you to and fro, to provide you distance times, to provide you how much fare they are going to charge you by calculating the distance from point A to point B. So Uber is using Google Maps for delivering service to you. Another example is, say there is a bank, right? So bank wants to offer you some, say, credit card or a loan or maybe an investment scheme. Now there are two ways: either they take their servers, build all of the software and then deliver it to you, or a smaller bank goes to a bigger bank. Okay, I want to offer my users a credit card. Can I use your credit card service? Can I use your credit card platform to brand it my own and then offer it to my users? That is platform as a service, because they are taking a already built platform, already built service and repurposing it, reusing it. And then we have software as a service. So software as a service is pretty much each and every application that you use over the internet, be it YouTube, be it Gmail, be it your Facebook. So all these are softwares that are providing some service to you. Even a simple chat application like WhatsApp is a form of software as a service, because you as a business can use WhatsApp to send out text about your business to other people. Okay, so any chat service, any full scale service that you're using, okay, you're logging into your Gmail, you're sending emails from one person to another. Maybe your company wants to set up an email server, right? They just go to Gmail. Okay, my company's name is AWS and I want an email server that should show AWS. But yeah, you can use Gmail or whatever service that you have in the background, but my user should be able to see only my brand name. No worries, we can do that for you, right? So that is software as a service. So I'll go to in detail of each one of these. So if you just read this slide, okay, contains the basic building blocks of cloud IT and typically provide access to networking features, computers, virtual machines or dedicated, and data storage. So what does a computer has? A network, a actual computing hardware, that is your CPU, and some storage, some hard drive, some SSD, some RAM is there. So IaaS is actually providing you that. You get direct access to that. So you log into your AWS account. I'll show you how we do that. And you get a server running maybe in 10 clicks. And if, say, you want to go to Best Buy to buy that same thing, you have to get out, you have to take your car, you have to go to Best Buy, pay for that server, bring that server home, get a specialized person to set that up for you, call your internet service provider to get the internet running on it, and then you have to keep it running, provide electricity, provide backup for it to just keep it running. And what AWS is doing is providing you all of that for a small fee. That is, there is no upfront charge. Say you want a second one, you have to again repeat that Best Buy process, but in AWS it's just same number of clicks away. And as we go advanced, there'll be, say, 20 text commands and you have your own server. So infrastructure as a service provides highest level of flexibility and management control. Why? You are getting your own server. You can talk to it however the way you want, and you can really take your value out of it with no upfront fees, no upfront charge, and huge amount of savings. And when you are doing savings for a company, that's when you are going to get paid. Because if you end up saving $1 million, a company would be happy to pay you $100,000 out of it. It's just a 10% commission, right? So platform as a service. So platform as a service removes the need for organization to manage the underlying infrastructure. So as I told you, Uber is using Google Maps platform to show you, okay, you have to go from point A to point B. This would be your fare. This would be your route. They're drawing that all Google Maps. How they're doing that? They don't care if Google Maps is running on 1 servers, 20 servers, 30 servers. In IaaS, you have to know, okay, I want 1 server on rent, 2 server or 30 servers. But in platform as a service, I just want my service, right? I just want this platform to work for me, and the rest of the capacity, the backend servers, the network, everything that Google Maps has to take care of. So that is where PaaS is. You don't worry about resource, you don't worry about capacity planning, you don't worry about any maintenance. The platform is there for you, you use it. Then we have our software as a service. Software as a service is like Gmail. So when you log into Gmail, you don't really care if Google is using 50 servers for you or 5 or maybe 1 server. You just go there, type an email and send it over, right? Similarly, you are on YouTube, right? So you go to YouTube, you click on a video, you watch that video, and you are on your way. You don't care if that video was delivered to you by one computer that was sitting right next to you or from a computer that is thousands of miles away. You just want your video to be used. So the underlying infrastructure, everything, you don't have to think about that. You just have to think about the service, that particular piece of software that you're using. Say I'm a smaller bank. I go to Goldman Sachs. Hey, Goldman Sachs, I want 20 people taking my credit card, but I don't want to build a huge software system for that. Can I use your software system? So that's what Apple did. Imagine Apple, biggest company, one of the biggest companies, they wanted to have a credit card out there. They didn't invented the whole credit card system. They just went to Goldman Sachs, asked them, okay, we want to offer users credit card. Can we take your backend? Can we take your service and just rebrand it as our own and offer that? Perfect example of software as a service. Say you have a company, you want to have your own email ID. Okay, go to Gmail. Ask them, okay, I want a Google domain. I want that service, but I don't want to jump through all the hoops of setting up my own Gmail server. Just give me an endpoint, just give me a web ID, just give me a URL, and I'll provide that to my users. No worries. Here you have it. So that is how software as a service works. So then now we have discussed about the cloud models. So cloud models, what are cloud models? How cloud models different from the cloud services that we just saw. So whatever model is out there, that depends on where that cloud is located, where those servers that you are taking on rent are located. And the service is how you are taking them on rent. You are taking directly the server on rent, you're taking the platform, or you are taking the whole software as a whole. So now we come to deployment models. The basic deployment models that are mostly used are public cloud and private cloud. There is hybrid cloud as well, but it is kind of small. Maybe depends on the company that you are going to work for, depends on the company that has already implemented. So I'll go to each one of these one by one and explain to you what public cloud means, what private cloud means, and what hybrid cloud means, right? So let me go to the public cloud first. So public cloud is actually the cloud that anyone can use. So say we are 10 people here, right? And all of us want access to a cloud, right? We can go out there and ask Amazon to give all 10 of us accounts. They'll do that for you because it's public. We can ask Google Cloud to give us accounts. We can ask Microsoft Azure to give us accounts. No worries, you can have those. Because everything in public cloud is managed by a cloud provider, say in our case, Amazon, and they are giving you that capacity out there, and you can take that capacity on rent and you can use that. When you're done with it, you return that capacity away and you are happy. You can access all these services via just your web browser. So I've been working remote for last 2 years. I have not been into a actual office of a big company in last 2 years. You want to know why? Because I am a public cloud expert. I just sit in the comfort of my home. I just have my laptop, my web browser open, and 99% of the things that I do on the daily basis just require an internet, a laptop, and a web browser, right? And if you want to talk about the hourly rate for a good cloud expert, it's upward of $500. And I'm not joking. It's just a middle range rate. I'm not talking about huge numbers here. $500 per hour is the rate for a good cloud expert out there. If you are certified, if you are not certified, if you know your thing, you get paid huge, right? And you don't have to even step in an office because you can work remotely. Maybe you have kids, maybe you have a life to take care of, maybe you have your parents to take care of, maybe you have your community to serve, maybe you want to take a vacation. You can be working on a vacation because you have internet, a laptop, and a web browser, and you can do pretty much each and everything that you need to do in a public cloud, right? So cloud-based application is fully deployed in cloud. All parts of the application run in the cloud. You don't have to talk to anyone. You get a work. Okay, this is my website. I want this hosted on AWS, and I want you to manage it. You go out there, build the AWS infrastructure, charge a handsome fee, and you are on your way. You can do freelancing work. Just go to any freelancing website and search for cloud jobs. There are thousands and thousands of jobs out there. And those are only for the people who know their thing, right? So it's not like super difficult. It's not like super easy. If you just put maybe 5% or 10% of the effort, you're going to ace it. That's my guarantee. Because when I started 10 years back, 12 years back, cloud was not, nobody knew what cloud was. And there was no trainings out there like this one. There was no material out there to learn cloud. And still, it just got me little over than a month or so to learn that cloud. And that's what we have here. We have a little more than a month to learn this cloud, and we are going to ace it. So let's go to private cloud. So what is private cloud? Now, imagine a scenario where you already have a data center, right? So till now we have been talking into the scenarios that we don't have our data center, we don't want to set up our own data center. But let's imagine a scenario where we have our own data center. Okay. Now, when we have our own data center, we want savings too. So obviously we want to move to cloud. But what to do with the current capacity? I don't know. You're not going to throw that away because you have hundreds and thousands and millions of dollars invested in that data center. Another case, say you are a HIPAA company, you are providing health insurance, you are a hospital. You don't want your data out there in the cloud, right? You want some of the very private HIPAA data, the health and personal data, the personal information data, the credit card information. You don't trust even Amazon with it. Even though they have everything on you, you don't trust Google with it. So what you want to do, you want to keep that within your data center only. For all your public applications, you want those savings, but yes, you want to protect that data and you want to use your existing data center to its capacity. So what you do, you go out there, similar to AWS, you set up a cloud in-house in your enterprise, in your own data center. How you do that? There are hundreds of software out there. Famous one is OpenShift. OpenShift is provided by Red Hat. It's open source software, free for use. Set up it in your data center. Many people have heard about VMware. So VMware was the first one to offer actual private cloud. You have your huge servers and you get smaller servers running on it. And whenever you want to terminate them, you terminate them. You want to spin up more VMs, you spin up more servers. So it's kind of it's a niche market. It's a small market, but yes, it's out there, right? Then comes the hybrid cloud. So hybrid cloud is what most big enterprises work. So private cloud is when you have your own data center, you just isolate it from public cloud. But if you want your existing data center and your public cloud provider to work together, you go to hybrid cloud. So hybrid cloud will let you utilize the capacity on premise as well as your own data center as well as your public cloud, say AWS. So say I have 100 servers in my data centers and I want 100 more. So what I do, I connect my existing data center to a AWS, right? So AWS now has direct connection. We have direct connection to AWS. Whenever I want more servers, I just keep expanding AWS. And whenever my servers are no longer required, I just pull back from AWS and just use my existing data center. I don't buy new servers for my data center, no. But yeah, if there are servers there, I should be using them, right? So we are binding public as well as private cloud together. So this gives you more flexibility because you have an option to run on premise or your cloud, because you can run anywhere, no worries. You can use your existing infrastructure, you can optimize it, you can use it to full capacity, and if you want to expand, the public cloud is always there. And if you want to keep your data secure, don't put it out on the cloud, just put it in your data center. It's in their backyard. So say somebody comes for an audit, okay, here is my data in my backyard, you don't have to look in my public cloud. So you are safer that way. And compliance, yes, when you do audit, you get compliant. So till now, we've been just going around what cloud computing is, how it's done, what are its uses. So I'll show you something, right? This is Magic Quadrant for cloud infrastructure as a service worldwide. So Gartner is a company which runs various analytics out there, and they analyze the market, where market is heading. So this was published in July 2019, and it's same now as well. Even if you look at right now, AWS is even higher, and Google and Microsoft are trying to catch up. But I'll show you another slide where you will see, okay, they have no chance. So in the bottom half, there are niche players like IBM, Oracle, and cloud. Very small, very few selective cases. Don't have to worry about it. In the top quadrant, there are leaders, right? So leaders are Google, Microsoft, and AWS. See how AWS is much higher than Google and Microsoft, because AWS controls close to 50% of the market share. Amazon actually loses money on online shopping. If they didn't have AWS, they'll be out of business by now. So if you look at Jeff Bezos' empire, this is his empire, right? And Amazon is right there in the middle of it. All these companies, 80% of these are actually losing money. But the AWS is such a great company, such a great business, because whatever capacity they have, they're using it to the full. That you are taking the services on the rent, it's lighter on you, it's great for them. And that has sold this particular individual to the most wealthiest in the world. And AWS, I would say, contributed to 90% of the debt. So if you look at the public cloud market share, this is AWS. It's 47%. So 47% of the market in 2019 is controlled by AWS. So if you are going out there, if there are 100 jobs, 47, 48 of them will be in AWS, right? And if you know AWS, it's very, very easy for you to pick up Microsoft Azure or Google GCP. Reason being because AWS is the most complete cloud that is out there. It's easier for the beginners because it's very well laid out, and it's great for the expert as well because it really has the power that you can tap into. So people ask me, why do you teach AWS? This particular slide is the reason, because you want your students, you want your patrons to succeed. And if you can give them an edge of 47%, that is a pretty good edge to succeed in a competitive market that is out there, right? So why AWS? Because it controls close to 50% of the market share that is out there. This is the reason why AWS is such a huge thing. This is the reason why cloud computing is such a big market. This is the reason why AWS leads all of them and why you should be learning AWS. This particular slide is the reason. I would like you to save this slide, take it screenshot, whatever, and just look at it while you are doing this training, when you're doing all the labs, because you are going to tap that 50% of the market. You are going to tap that 50% of the market of the cloud computing that is out there. And it's a huge, huge market, right? You are going to be the Amazon Web Services expert. Once you do this training, do some labs with me. I'm here to answer your questions, and you can do that. So till 2016, Amazon was completely concentrated in core business, that is e-commerce. So everybody knows Amazon.com, okay? One day shipping, free shipping, expedited shipping, good deals, Black Friday sales, Prime Day sales. There are huge amounts of sale. You get really good stuff for cheap, and they were just concentrated into that. But as I told in the starting slides, you are Amazon, right? So say you are having a Black Friday sale. On Black Friday sale, say 1 million people log into website. On a regular day, maybe 200,000, maybe 300,000. So you have 700,000 people worth of capacity just lying there idle whole year. You're not using it. So Amazon thought of a brilliant idea. Why don't I give this capacity on rent? I am not using it. Somebody else wants to set up their company. They don't want to set up the whole data center. They should be using it. So how Amazon did. In 2003, these were two guys, Chris Panican and Benjamin Black. They presented a paper how Amazon's internal infrastructure looked like. So they went into the data center, looked around, and wrote a paper about it. Okay. And as soon as they published that paper, they prepared a business case. Like, we are running a data center that is huge. We have a lot of capacity that is there. I think we should give this as a rent out. So the first service that launched was SQS, Simple Queue Service, which was just a simple service where you say, okay, I want these 10 jobs to be done, and I want these jobs to be done one after another. Take a really small amount of compute power. You just have to tell which one to go first and which one to go second, and you do that. So it was a great success. And in 2006, AWS was officially launched. Amazon launched a full-scale services around compute, where they was renting out servers, where they were renting out hard drives for storage, they were renting out networks, they were renting out databases. These were the basic offerings that they started with. And from 2006, it has grown ever since. Today, AWS has huge amount of services. There is not even a single service that is not there in AWS that any other cloud provider has. In fact, 90% of the services that AWS has are copied by other cloud providers. Amazon was the first, Amazon was the original, and Amazon is the original till date, because even today, there are around 15 services that are available only on AWS that are not available anywhere else. I'll tell you an example of a very niche service, and I don't think anybody else can implement it apart from AWS. Amazon even lets you have satellite stations on rent. Say you want to connect to a NASA satellite or any other broadcasting satellite, or you want to relay your message to the remote areas, you can have a satellite station that takes millions of dollars to build. You can take that on rent and you can really use that. So this is the power of Amazon, because with Amazon, you can really have that power. Imagine renting a satellite station, renting a satellite capacity on, it's just crazy. No other cloud provider would even think about it. That's why Amazon is the leader. Okay. So in 2010, all of Amazon.com moved over to AWS. So whole of Amazon.com's global traffic is on AWS. So if anybody says, is AWS okay? Will it perform? Just ask them, have you ever been to Amazon.com? They'll say yes. Have you ever find it slow? No, because it's working. Why? Because it's on AWS. I'll show you the list of the companies that are on AWS and you'll be really surprised. And these are all different numbers. You can go all anywhere on the internet. But the main gist is how AWS started and how it has led till date and how it is going to lead in the future. So this is AWS's mission. Enable businesses and developers who use web services to build scalable and sophisticated applications. So you're using web services. Yeah, AWS. You are building scalable. Why? Because you can rent hundreds and thousands of servers. It's very sophisticated because you have all the services here and we can use that, right? And it's sophisticated. That depends on your developer, right? You cannot guarantee sophisticated. The sophisticated will be guaranteed by who? The user as well as the developer. As a cloud expert, you just have to build the part. What to run? Your developer will give you the code, right? So these are the quadrants. See how AWS is up there. And yeah, in 2018, AWS slipped small part. But yes, in 2019, as I showed you earlier, it was way ahead now. These are all the companies, just only the startups that are there on the AWS or the companies. So look at it: Workday, LinkedIn, Pinterest, Airbnb, SoundCloud, Dropbox, Tumblr. Each of these services have more than 500 million users. Each of this service, the top shelf, has 500 million users. You have Shazam, you have Spotify, Etsy, TinyCo, Reddit. All these services are heavily used, and if they are trusting AWS, if somebody comes to you tomorrow, why should I go to AWS? Just show them this slide. If these companies are on AWS and doing hundreds and millions and billions of dollars in revenue, I should be on AWS too. Because to run the services at that scale, they must be really smart. And if they have chosen AWS, I bet they are. These are the big companies. Those were the startups. These are companies. Look at that: Unilever, Shell, Thomson Reuters, GE, Qantas, Comcast, Samsung, Nasdaq. Each one, we use each one of these companies on a daily basis. You're using Expedia for your ticket booking, Adobe for reading PDFs, McGraw-Hill for the books, Pfizer, Lamborghini, Getty Images. All of these services we are using on daily basis, and they are coming right to us from AWS. We don't notice it because it's all working in the back. But yes, they are coming to us from the AWS. They are being delivered to us via really high quality cloud provider. And all these companies are running their business on AWS. And that means it's a proven platform. It's not something new. It's not something that is yet to prove its worth. It's a proven platform, because you don't get this many companies, this many huge enterprises to come onto your platform and host all their website, all their customer data, all their transactions on your website, unless and until you are good. So this is it. And I'll quickly jump to the AWS console. So whenever we'll create an account in this class, and when you create an account, this is how it will look, right? And if you want to look at the services that are there, don't worry about it if you don't understand it. It's just a website, just simply like Amazon.com. You just have to click on bunch of stuff, add to cart, and you are on your way. It's similar to that, and it's very easy to do. Don't worry if you don't understand all this, but I bet in maybe 2 weeks you will be able to make sense of all this, right? So I just wanted to get you into the zone today, explain you about the basics. And this is what when you log into, say, AWS console, how it looks like. I'll give you the link. We'll create an account for each and every one. You have to go there, use it, because unless and until you are doing practicals, you won't know. I can speak everything here. I can tell you, okay, this is cloud, this is how I create a server. But unless and until you do it with your own hands, you're not going to master it. And this AWS account is free. So you don't have to worry about paying for that. You just go out there. It's similar to creating an Amazon account or a Gmail account. Just go there and create an account, and you are on your way. You don't have to worry about, okay, I have to get access from there or there. It's free. It's free for use, and you won't get charged for it. As long as you follow the labs exactly I say, you are not going to charge, because it's very easy to. So whenever something is too good to be true, it probably is. So you have to use each and everything with caution. It's similar to a credit card. Okay, you have a credit card, you have a credit line, but you shouldn't be swiping it for each and everything, right? So similar is the case with AWS. Use it only what you need it for. Don't go out spinning unnecessary things, because you are going to get charged if you start using it out of bounds, right? So if you follow my labs, if you follow me, you are going to have a great time using AWS, and in no time you will be able to learn it. So these are all the services. So look at these services. Go to any other cloud provider's website, you won't find this many services. See how many are there, right? So these many services actually give you a huge amount of flexibility to do whatever you want. There isn't a use case when you want to run something and that is not there in AWS. And you don't have to learn all of this as well. You just have to learn the important bits, the bits that are used in your daily life. Because once you learn that, you will be always be able to make sense of the new ones. So new services get added to this every month or every 2 months, right? I learned AWS 12 years ago, but when you start using it, you will pick up new services very fast. So don't worry about it. And we will explore each one of these in detail, whatever that is important. And once you get a sense of it, once you really get the sense of it, you will be able to go out there and get those jobs, and it will be very easy for you. Okay. So AWS Global Infrastructure. So this is session 2. Let's start. So these are the objectives of this session, what we are going to study, and we will go over each of this in detail as we go along. We will start with what is the state of AWS Global Infrastructure, where are its regions, what it is a region, what is availability zone, what is a data center, how to choose a AWS region, what are the different security features that are out there, a brief introduction to AWS resources, what are major type of resources are there, and then we are going to group those resources, and then we'll have a small look at AWS Marketplace. So this is more of a general introduction, and we will go over these topics in detail, right? So what is the AWS region? AWS region is a physical location. Let me give you an example. US is a huge continent, right? North America is a huge continent, and there are so many places that users are there, right? So you want to have your data center as close to your users as possible, right? So the closer the computer is to me, the faster I'm going to get the downloads and the uploads, right? Say you are streaming Netflix. So by the way, Netflix streams off AWS only. Now, say I am a Netflix user and say I am in maybe Connecticut, right? And my data center is all the way there in China, or maybe it's in remote parts of Europe. So my data has to travel around half a world to reach to me, right? The farther the data has to go, there would be higher latency, because the farther a thing has to travel, it will take more time. Yeah, you have to have a huge amount of capacity going there, and these are separated by huge oceans. So you either have to have a very strong satellite network or very good cables in the ocean to get your data there, and it's expensive stuff, right? So AWS has provided you around 22 regions, 22 separate places where you can have your data centers around the world. So if I quickly go here and see the map where it is, if I go there, here I am on the global infrastructure. This is AWS site, aws.amazon.com. And you see these blue dots, these are the actual AWS regions. So what they have done, they have scattered their data centers all over the world. So no matter where your customers are, maybe you are a company based out of just one continent, just one country, or maybe you have a global business, like say GE has a global business, Netflix has a global business. So it doesn't matter where the users are, you will find a AWS region fairly close to you, and you can serve the data off there. So when you are designing an AWS solution, when we are deciding, okay, where should I put my capacity, you can leverage any one of these locations, and you can be really close to your users, because the closer you are to your users, there is a lower latency, you can deliver better experience, and they can have great experience while they are consuming your services. And you as a company get the flexibility of not keeping your data at one place. So let me give you an example. So there is this data center in India, Mumbai. So let's say, God forbid, there is some natural disaster and there is a power outage in Mumbai, right? Maybe there is a power outage in Sydney. Now, say you are in only one place, and you have your data all scattered only in Sydney or only in Mumbai, right? So unless and until the power is restored, maybe due to some natural calamity, you won't be able to get to that data. So your users will experience a downtime. Now imagine this. Maybe you are a news agency. So in the time of a power outage, in the time of a calamity, your users need you all that more, because they are going to want to have latest news. And if you are also affected in that, you cannot deliver news to them. But with AWS, you can scatter your user data maybe in Mumbai, some in US, say US Gov Cloud, in US East, you can have some in China, you can have some in London. So unless and until there is a catastrophe along the whole earth, you are pretty much covered. So you can have your services online, you can have your services always working, because even if one region is affected, your users are not going to affect. Imagine doing this when you have your own data centers. Imagine going around the world, buying properties on each and every continent, and setting up your own data centers, right? You need to do onshore hiring, you need to do a lot of hiring in these different places, you need to do big buildings, you need to put a lot of server power in there, you need to have coordination between all these teams. So now, whether you are sitting on the East Coast or the West Coast, you can deliver your services to whole of the world, just sitting right in your office, without having to actually go to India or maybe Australia or maybe China or maybe Europe, right? Because at a click of a button, AWS has provided you the power to have your compute resources at the 23 global locations that are separated by each other on different continents, powered by very high speed internet, redundant, and so on. Now, these are the regions, right? So these blue dots are the regions. Orange ones are the ones that are coming soon. So AWS is continuously expanding its capacity. It's not like, okay, we are done. No, they're expanding. They're putting more data centers in, right? So in Mumbai, as you can see, there are 3 availability zones. So availability zone is a physical data center. A region is where all the data centers are. Availability zone is the actual data center is there. So even if Mumbai is a region, they have built 3 separate data centers in Mumbai, separated by at least 100 kilometers, to provide the redundancy within the region as well. So it's not like, okay, one data center is gone and your region is gone. No, you have 3 data centers there. If you look at Sydney in Australia as well, there are 3 data centers there, 3 availability zones. Say you go here in Canada, there are 2 availability zones, each separated more than 100 kilometers apart. So say you go to Ohio, there are 3 data centers, each separated minimum 100 kilometers apart. So even if there is a small power outage in one area, you have 2 other data centers that are up in that region as well. So you get a global redundancy by having multiple regions around the world, but you also get a local redundancy by having multiple data centers within that region as well. So look at this US East GovCloud. Look at Virginia. There are 6 availability zones there. You get 6 different data center in one region or separated by more than 100 kilometers. So if you go here, California has 3, right? Oregon has 4 availability zone and 1 local zone, right? And then you go here, GovCloud. This is GovCloud. So only the government websites run on AWS GovCloud. So imagine the scale of AWS. They have even provisioned separate regions for only US government's workloads. So US government is a huge customer of AWS. So huge that they have built 6 different data centers, 3 in US West, 3 in US East. So they have provided 6 dedicated data centers for US government to host US government's workloads. So be it Department of Defense, be it NSA, be it your public companies, your healthcare, all are customers of AWS. So when you are going out there, okay, you want to select a provider for your workloads, you want to go with the best. And government doesn't rely on anything that is short of best. So it's not like, okay, they came into existence now. They've been in existence for more than 8-10 years now. So for last 10-15 years, AWS is the leader, and it will continue to be the leader because it has such huge capacity, huge presence around the world, and each of these regions has a minimum of 2 or 3 availability zones, with more coming up. They are building, continuously expanding that capacity. So you have a global infrastructure that you can really depend on. So as I said, AWS region is the physical location where your AWS data centers are located. So there are around 23 regions at this moment that are active. And then availability zone is a single data center in that region. So there are a minimum of 2 or 3 individual data centers in each region. So if you look at here, if you want to read the slide, they have a huge capacity, 25 terabits per second bandwidth going between each of them. So they have huge optic fiber cables running between these data centers. So you get really good connectivity. They are multiple kilometers apart, and the latency is very less, 2 milliseconds or 1 millisecond. So you get a truly redundant infrastructure that you can really rely on. So AWS region is the global space where AWS is located. These blue dots are the regions, and then you have availability zones. Availability zones are the individual data centers that are there in this region, right? So say Bahrain has a region, and there are 3 availability zones that are separated at least 150 kilometers apart, 3 individual data centers connected by a very high speed internet, redundant power, minimum 3 different sources of power with backup generators and everything. So even if your region is going down, even if your one data center is down, you are really up, you are really serving your customers, and you can really rely on this infrastructure, right? Because if you are down while serving your customers, you are losing business. And if you choose AWS as your partner, you are going to be pretty much covered in that area. So I talked about AWS data center. So AWS data center, a single data center typically have 50,000 to 80,000 servers. So now imagine the scale of it. So you have 80,000 huge servers. A single server can probably run your small business, small to medium enterprise, and you have 80,000 of those in single data center. And each region has how many availability zones? 3, 2, 3, maybe 6. Like in the case of Virginia, we saw there are 6. So in Virginia, they have the biggest presence in Virginia. They have almost 100,000 physical servers in one data centers. So that gives us 600,000, more than 500,000 servers in one location. Now imagine you are going there, right? You're a small enterprise. You are going to probably need at the start maybe 10, 20, 15 servers, right? They have 600,000 of them ready for you, waiting for you to run your workload, right? Amazon has the scale. They're a huge company. They have the scale. They can work on it. So a single or a couple of data centers are clubbed into one easy, and it is really hard to get how many data center of Amazon operates, because Amazon is so huge. You cannot really put numbers on Amazon. So they do almost $1 billion in quarterly revenue in just small consulting. So if you look at their AWS revenue, it's more than $60 billion. So when you want to earn $60 billion off of a product, they are really invested in it. So every year they're spending billions of dollars expanding this capacity, maintaining this capacity, hiring the best of the talent, hiring people who can really run these servers and give you that flexibility that cloud provides. Now, the story doesn't end at regions and AZs only. Then they have AWS edge locations as well. So, okay, you have a region, you have multiple availabilities, great. What if you want to be even closer to your users, right? So right now you have around 24 regions. Each on an average, we say they have 3 availability zones. So total comes out to be 72 data centers almost, right? But these sometimes you want to deliver content even faster. Say you are Netflix. Whenever you want to click on a title on Netflix, you want that to load instantly on your user's phone. Say you want to host an online gaming. For gaming, you need a very low latency, else your players will die, right? So then you have the flexibility of using CDN at AWS edge locations. So edge location is just a mini version of a data center. It's not a full-scale data center with 50,000 or 80,000 servers or maybe 100,000 servers. It has around maybe 4,000, 5,000. So they got that mini, still they have 4,000, 5,000 servers. 5,000 server is still more than really big enterprise that are out there. So I remember one of the clients that I worked initially, so they were just beginning their journey into the cloud, and they had 2 data centers. They were based off New Jersey. So they are a huge company in New Jersey. They provide insurance to maybe 70% of the people there. And what they were doing was they had 2 data centers, each separated by around 20, 30 kilometers. So they had a difference about 30 miles between each of these data centers. And there was a huge snowstorm, and that knocked both the data centers out. Now imagine you are going to the hospital in snowstorm, people get injured, and you're not able to get to your insurance provider. It's a very dire scenario. Imagine getting stuck with your claims not getting processed. You have nowhere to go because there is a snowstorm, and your company being local, they don't have a global presence, and you're not able to get. So then they reached out to us, and we initiated their journey to cloud. So in each of their data centers, they were operating around 1,000 servers. So total 2,000, 2,500 servers. When they moved to cloud, they instantly scattered their resources across whole of the US, right? So now, even if there are issues on the East Coast, they have capacity running on the West Coast. Even if both coasts are affected, they have central US catering to the capacity, right? So you get the power of scale. You are distributed across a whole continent, and you are really able to utilize that capacity whenever you need. And to shift data from one place to another, it's just a few clicks away. Imagine shifting data between 2 data centers that are just 30 miles away, and you have to like ship the data in carts and your trucks and everything. It's going to take time. What if both data centers are out? You can't serve your customers, right? Your customers are stuck. But yes, if you have AWS as your partner, they chose AWS as a partner. And since then, they never have even had an outage because of a data center going out, because of a server going down, because it really gives you the capacity, right? So what is the AWS edge location? Back to it. So edge location is like a smaller data center. So what they have done, if I quickly pull up the page for AWS edge locations. So whenever you are in doubt about AWS, just Google it. There is huge amount of material that is out there, and you would be able to get it to it really fast because AWS is such a mature product. A simple Google search will get you there, right? So if I go to the AWS edge locations, and it will take me to the Amazon link as well. Look at these. This one has both edge locations, multiple edge locations, and regional edge caches. So look at these circles that are there. So in regions, we had around 23, 24 regions. For my CloudFront points, my edge locations, I have more than 100. So I'm covering 50 cities in 23 countries, right? And it is ever expanding. It's not like they are, okay, we have built like 100, so we are done. No. Even these slides won't be able to match the speed they are going in. In a single day, maybe they'll be adding 2, 3, 4, 5, 10 more edge locations, right? So these are the locations that are currently there. So this is article 98, 9900. So just like a ticker, and this is a 2017 report from the AWS official website. They have grown way past that number right now, right? So if I go here and if I look at this, look at it. See, wherever your users are, you can really get to them very fast. Maybe they're in Europe, maybe they're in Australia, maybe they are in Africa, maybe they are in South America, maybe they're in North America. You can deliver your infrastructure there with the power of AWS. So edge location is kind of a mini data center, and because it's a smaller, they can build it a lot faster. Whenever they see, okay, this region, this particular location in a country is not able to get to us really fast, no worries, we'll put a small data center there of 5,000 servers, and we will figure out how many regions more we have to build, because regions and bigger data centers take time to build. There are huge infrastructures. 5,000 servers, they can just rent out a building and put a CDN there, put a edge location, right? So this is the slide that I showed you earlier, and these slides were built about a couple of months ago. And you can see in Mumbai, they have already built one more data center, because I show you they have 3 availability zones, right? So US is pretty much there, updated, but yes, rest of the world, they are really adding things very fast. At that time, in 2 months ago, there was no Middle East region. They have that region now, right? So they keep adding. You cannot keep updating your slides fast enough for AWS. AWS is really fast. You have to put a lot of effort to catch them up, right? And this is the features that come with all this infrastructure. So you have high availability through multiple availability zones in each region. Each region has minimum of 2, maximum of 6, and on an average 3 availability zones. So you get 3 data centers in a single region, which really gives you high availability. Even if one of the data center goes down in a region, your region is not offline. You have 2 more data centers there. And even if your region is down, you have 24 other regions, 23 other regions to take care of your workloads, right? So meeting compliance and data resiliency requirements. So Europe has compliance issue, where if a citizen is from Europe, from certain countries, his data should be hosted in that country. US has that for PII data. So if it's a personal information, personally identifiable information, it's a HIPAA data about your health and your insurance and everything, it should be stored on US soil only for a US citizen. So say you are a global company, right? And you are providing insurance all over the world, right? So you want your Europe's patients' data to be in Europe only. You want your US data in US only. You want your Middle Eastern data in Middle East only, right? You can have that with AWS, because AWS has a true global presence, and you can utilize their different regions to put the data right local to that country's government, where you are compliant, where you are easily able to pass the audits and everything. Okay, so say today you are in US, tomorrow you want to expand to Europe, third day you want to expand to China, fourth day you want to expand to Africa, fifth day you want to expand to South America. You can. You don't have to make plans for say 5 years in advance and go out, send your executives out there to scout the places to build your own data centers, purchase huge amounts of land, build the buildings there, purchase servers, hire staff there. No, you don't have to do that now. Because even when you are sitting in US, even when you are sitting anywhere in the world, you can manage infrastructure all over the world. And the infrastructure is there with AWS. And there is improved continuity with replication between regions. So even if one of your region is going down, Imagine a whole region, 3 data centers go down. It rarely happens, but yeah, it can happen. There is a natural calamity, there is a power outage, anything. You have replication between other regions. So even if Sydney region is down, you can deliver to your customers from Singapore, maybe from Japan, maybe from Hong Kong. So you get high availability, you have continuity, you have no data loss, and you are able to serve your customers better, right? So how to choose a AWS region? Now, we know there are around 24 regions, right? So as a AWS solution architect, when company comes to you, okay, I want my data out there, I want to move to cloud, but which cloud? So answer is AWS. Okay, where in AWS, right? So if you look at AWS, I showed you there are around 24 regions, right? Where you want to put your data. So two basic things that will influence this decision. First, you want to be closer to your users, right? So the closer you are to your user, faster the data can travel to them, and they experience lower latency, and that leads to a better user experience. Number one. Number two, do you have a compliance issue, right? You want to satisfy laws of a country where you are doing business in, right? So say you are maybe a European country and you are in business of healthcare and you want to serve US customers. Now US law dictates that the customer data from US patients or US customers should be in US only. No worries. We will spin up our infrastructure in one of the AWS regions that is located on the US soil, and you're good to go. So the main decision is where you can serve your clients better, where you can serve your clients really quickly. And the second decision is where can you get the compliance and everything. Okay, so choosing between based on latency, global warming, cost, and compliance. Now let's go to the cost. Though AWS is a global infrastructure, but there are slight differences in how you are charged for each of these resources, right? So say you want to rent 100 servers, right? So, okay, I want to rent 100 servers. If you select it somewhere that has cheaper labor, cheaper power, cheaper server cost, cheaper engineers that are maintaining those, definitely your server cost will be cheaper, right? If AWS is very mature in that region, I'll give you an example. So AWS is most mature in Virginia because they have 6 data centers there. They have huge amount of capacity there. If you ask AWS for a server in Virginia, you can really select when you're spinning up the servers. Okay, you want computer in Virginia, it will be cheaper by a few cents than spinning up in a remote country or in a remote location like Hong Kong. Okay, so in Hong Kong, they have to jump through a lot of hoops to build regions there. Okay, so the internet connectivity is a bit expensive. The real estate is very expensive in Hong Kong. So they have to put a lot of more capital in getting regions up there, getting data centers up there. So you probably have to pay a couple of cents more to get a server there than in Virginia, right? So, okay, cost might not be a factor for a huge organization, but yeah, if you're a smaller business, you really have to think about the cost. Okay, how much cost I can bear, how much is going to cost. So you have to have those estimates really with you. Then there is global warming issue. You want to be as green as possible, right? So to take that into account, you want your servers to be in a region that is naturally cold, right? So to cool a server, like a small laptop, you have 2 fans, right? Now imagine cooling 100,000 servers. Okay, you need to have huge chillers and everything. They throw away a lot of heat, right? So if your data center is in a naturally colder region, right, you need to run less of those chillers and you are more green. You're not doing that much emissions and everything. So say your organization has a target of going carbon neutral, right? You don't want a huge amount of emissions going out because of you. Yeah, you can select a region, maybe in Canada at a someplace cold, and you can be compliant to your global warming issues, right? And latency is obviously the number one choice because you want to be really close to your users so that they can really leverage the infrastructure really faster. You can deliver a better service, right? So say if a Netflix video takes 20 minutes to buffer and it's a half an hour video, your experience is spoiled. But if a same video loads in half a second or maybe a second or maybe under a minute, your experience is great. Customers will come back to Netflix, right? But if it's really slow, why YouTube works so well? Because it's very fast. Wherever you are using it, it's really fast, right? So you can really reach your customers really faster if you are closer to them. Now comes the question of security. Okay, so you have AWS, right? And you want your data to be secure. What if, because you want it to be safeguarded against hacking, what if you put your data out there and it's just hacked, right? That is not a good thing, because you will get sued if you just lose customers' data to hackers. So you have to have your data very secured. So what AWS does, AWS enables a shared security model. Now, how that a shared security model works? Number one, what they will do, they will protect the data centers from the intruders. So you don't have to worry about someone just going inside their data center, plugging their hard drive into the computer and just downloading their data. No, they're heavily guarded. They have fences and everything, guards and good access control around the data centers. Even if Amazon employee wants to get into a data center, they cannot unless and until they have a work there. They have prior authorizations from the concerned authorities at AWS, right? So your data is physically secured. Nobody can walk onto a computer that is running your workload and just download your data. Okay, physical security is there. What about the cyber security of your data? So here things get a bit tricky. How they get tricky? So say you have a server, right? And you have put the data in your server. Now keep storing the password to that server, because you are the one who is setting the password, right? You have to have a strong password. You are not to share that password with anyone. Similar to your email account, right? So if you give your password of your email account out there, anybody can log in, right? If you give your credit card number out there, anybody can do purchases of your credit card, right? So similar is the case with AWS. If you want your data to be secured, select good passwords, tough passwords, and don't share them with anybody. So physically, they are storing your data, they're securing your data. But cyberly, in terms of IT perspective, you have to have the controls there. You have to put rules and you have to put strong passwords there so that your data is protected from the cyber attacks, right? So network intrusion is taken care of by AWS. But yes, if your server is out there and if you do a weak password on it, it will get hacked, right? Because there are a lot of hackers, a lot of malicious people around. It's similar to securing your own PC. If your PC's password is really easy to guess, anybody can log in, right? So you get access to hundreds of tools and features to help you meet your security objectives. It's not like it's all your responsibility. AWS provides you tools and everything. We will explore those tools as we go along, and you can really secure your infrastructure, right? So you can have full control over your network security, your configuration, your access control, who has access to what resources. So maybe you are in an organization and there are 3 departments, right? One is a finance department, one is a marketing department, one is a developing department. So you don't want financial data to be handled by marketing or development people. You can have that. You can create financial users and they will have access to only finance servers. You can create development user and they'll have access to only development servers. You can create marketing people's accounts and they'll have access to only marketing resources. So you can really put access control out there. AWS provides you tool, but it's your responsibility. Why it's your responsibility? Because AWS doesn't know your organizational structure. Maybe you are a single person. You need access to each and everything. Maybe you are a company with more than 10,000 employees spread across different departments. Everybody needs access, but everybody needs to have a limited access. AWS doesn't know as a customer what are your actual requirements are. So they provide you tools to accomplish all this. So benefits of AWS security. AWS puts strong safeguards to protect your privacy. All data is stored in highly secure AWS data centers, right? You meet compliance requirements. Why? Because AWS gets their infrastructure audited for HIPAA and everything every year whenever it's required. They are PCI certified, they are DSS certified, they are HIPAA certified, they are PII certified, they are GDPR certified, that is new law originated from Europe. You save money because the higher standard of security come to you as a part of AWS, and you can scale quickly because no matter where you are, no matter what's the size of infrastructure, AWS has it for you and your data is safe. It doesn't matter if you're running 100 server, 1 server or 10,000 servers on AWS, you get same security standards as a huge government organization, as a huge multinational will get, even a small or a medium enterprise gets same security standards. You have same controls. AWS put really power in your hands in terms of security. What about compliance? So these are all the certifications that are required to run a business. There is SOC, there is FIMSA, DICAP, PCI DSS, FedRAMP, HIPAA, PII. So AWS gets its infrastructure audited every year by certified auditors and gets these certifications for you. How's that good for you? If you want to do that to your own data center, you have to pay auditors huge amount of money, right? But in AWS, because they're running each and every kind of workload, they ensure they are certified to each and every certification that is out there. It's not like pick and choose. They go out there and they say, okay, we are going to meet each and every certification, no matter how hard it is to achieve. So even if you are a small business retailer running just a flower shop, you have the same standard of audit and compliance as a big multinational like GE or Netflix, right? So whatever compliance power a Netflix or GE has when they are running in AWS, a small person running only a single server also has that same power, same features. So you can be really assured that AWS is robust in terms of data protection, in terms of privacy, in terms of compliance. So say you get audited by one of the companies, right? You get audited by the government. You can say, okay, I'm running in AWS. You have given the certification to AWS. I am certified as well because AWS has provided me that certification. So now we are going to step into AWS resources. What are the different AWS? So we have talked, okay, AWS does this, AWS does that. But at the end of the day, there are different products that you can use to accomplish your task. Those tasks are categorized under AWS resources. So the first service that AWS came up with, and it is the most popular one, is called Amazon Elastic Compute Cloud. It's called EC2. So whenever you go into an interview or as a part of regular job, this will be the service that you will be most interacting with, right? It is the first service that AWS came up with. So what it does, it gives you on-demand compute power. With 5 or 6 clips, you have a server running in anywhere in the world within 6 clips, and you can scale that server up and down. You want more RAM, you have it. You want more CPU, you have it. You want more disk space, you have it. And that server is instantly visible to the world, and you can quickly scale, quickly boot up new instances, and it is on demand. Whenever you want, it's there. And you can reserve your capacity. Maybe I want 30 servers just running for me all the time. You can have spot pricing. In spot, it's kind of a bargain. Okay, spot pricing is kind of a bargain. So imagine at some point of time, AWS is not seeing huge amount of capacity, right? There are not many customers right there in that AWS region. So what AWS starts to do, it starts reducing the price of its AWS instance, right? So say it's like $1 an hour right now, nobody is taking them. So what AWS does, it reduces it to maybe 80 cents that somebody takes them. Nobody is taking them. Let's reduce it to 60 cents. Nobody is taking them. Let's reduce it to 10 cents. When it's 10 cents, maybe 30 people want that. So 30 people can go there. Rather than paying the regular rate of $1, you can pay only 30 cents for an hour. So that really reduces your price, really helps you scale quickly, and really saves you money. So it's good for both AWS as well as you, because you get a reduced rate, and AWS is able to use the raw capacity because their servers are running anyway, right? They are consuming power, they are consuming cooling, they're consuming network and everything. So it's good to sell them for something rather than for nothing, right? So that's what the AWS model operates on. So what are the different operating systems that you get? You get Windows. You want to run a Windows machine? No worries. You want to run a Linux machine? No worries. You want to run FreeBSD? You want to run Solaris? You can run each and every kind of workload that you can imagine there, right? They have support for all major web, and so maybe you want to run Android application backend, right? You have it. You want to run infrastructure for iPhone? You have it. You want to run infrastructure just for your cloud, your web service. So right now, what you are saying, you are attending a Zoom meeting. Zoom is also AWS customer, right? So the data that is flowing to your screens right now is actually coming from an AWS data center, right? I am connected to one of 24 regions. I am connected currently to maybe somewhere in Europe. right? You are connected somewhere on the East Coast or the West Coast or maybe US Central, depending upon where the latency is lower for you, right? Because when I'm talking to you, latency has to be very low, right? If I talk something now and it reaches to you after 2 minutes, we cannot have this class, right? This class is possible only because we have very low latency, and that is because of AWS. You get me? And it's not like your servers are just running out there. You can monitor their status. Okay, how much it's being used. Okay, how much is it going to cost me? You get really good dashboards and you can just visualize them. Okay, it's great. I should be running it. I should not be running it. Maybe my server is running too hot. I want to increase the capacity, right? Say you are getting huge amount of users. Like right now we have around 10 people in this conference. Maybe 20 people join. Maybe I need a bigger instance. AWS will give me a bigger instance. It's just a few clicks away. Now I've done AWS EC2. I got my compute. Now I want storage. This storage is similar to your iCloud or Google Drive, right? So Google Drive is a Google product. iCloud is your Apple product. Amazon has a same product called Simple Storage Service. So what they do, they provide you an endpoint, they provide you a place where you can just upload your any files. Maybe there are claims file, maybe there are music file. In case of Netflix, it's video files. In case of Spotify, it's MP3 files, it's music files. In case of some finance firm, it's your audit data, your credit card data, anything. They just provide you that and you can just upload it. And it's available all over the world over the internet. You have a console, you just upload it there and it's there. Then you have Elastic Block Store. Elastic Block Store is kind of a hard drive. So like the hard drive you have on your system right now, maybe it's a 500 GB hard drive, maybe it's a 1 TB hard drive. So your server needs power too, right? Server needs hard drive too. So EBS provides you that. So these are just the compute components that are out there, but Amazon have relabeled them. Okay. So Amazon has renamed hard drive to EBS. It's just a hard drive. Don't get confused by this fancy names. They're just, okay, you're getting a server. Okay. You're getting a storage. Okay. You're getting storage on a hard drive block store. No worries. So in reality, these are just your simple compute components. They have put really fancy labels around it. Don't be confused by the labels. Just see what they actually do, right? So S3, just a storage. EBS, just a hard drive. EC2, just a server. Then you have VPC. So VPC is kind of a network, right? You are getting internet connection and everything. That is your virtual private cloud. Really fancy name, virtual private cloud. If you think, okay, I am getting a private cloud. No, you're just getting a small network out of it, right? So it just provides a logically isolated section of AWS. You have your IP ranges, subnets, route tables, all network things. They can come under VPC. ELB, Elastic Load Balancer. You have multiple servers running. You want load to be balanced across those. Okay, ELB. And we are going to study each one of these in detail in the coming classes. So here's how it's going to work. Each day we will pick one of these topics and we will explore it in detail, do practicals around it so that you know how each of these components work. This is just an introduction. Okay, this is out there, but we will really explore all these topics as we go along. Then you have Amazon Route 3. It's a simple DNS service. So whenever you are hitting a website, right, say www.google.com or amazon.com, actually you are hitting a server and that server has an IP address. Okay, we'll go into details. Don't get confused with the jargon, with all the labels and everything. Okay, so DNS service just provides that IP address in lieu of your name. So instead of amazon.com, you are actually hitting 64.6.11.190, right? It's just a number, but it's difficult to remember. So even if you imagine, you know, around 30 or 40 websites on top of your head, imagine learning 30 of these kind of numbers, 64, 611, 190, maybe 23, 160. You cannot learn 40, 60 of these numbers, but you can really learn these simple xyz.com, amazon.com, netflix.com, right? So at the end of the day, it's just going to one of these numbers, but rather than you remembering these numbers, a computer is doing your task. So in terms of Amazon, what that computer is called, Amazon Route 53. Then you have your Amazon Relational Database Service. It's called RDS. So RDS is like simple database. Okay. We've been running database in production for almost 40 years now, right? Each and every company has a database. You go to a bank. Okay. It's not in our database. You often get that. You go to a coffee shop. Okay. This drink is not in my database. What is a database? It's just a SQL normal table. Okay. This is the item. These are the details. So what is the AWS service for that? Amazon Relational Database Service, RDS. At the end of it, it's just a table where you can store a bunch of your data. Then you have your simple DB, non-relational database, kind of a spreadsheet, right? You have that. And these are all the services that are out there. So your application has access to all these services, as I showed you yesterday as well in the AWS Web Console. So let me quickly jump to the AWS Web Console itself and just show you there. So you look at these services. These are all the services. At the end of the day, they are just services, just normal computer things with a fancy name attached to it, right? So if you are from IT background, non-IT, if you know how to use a computer, you can pretty much use AWS. You just have to know, okay, I want a PC, I want a server in cloud, I want to go to EC2, I want to put storage, I want to go S3, I want to attach storage to EC2, I want to go to EBS, I want a database, I want to go to RDS, I want a network, I want to go to VPC, I want a DNS, I want to go to Route 53, and these other services as well. They're just modified versions of these. So the basic services that I told you are those 6 or 7 services. All other services are special use cases for those services. They have modified that services, made it more managed, more intuitive, more developer friendly, and they have come up with all these services. So this web console is really your entry to AWS. All these services are there, and we will explore each of these services in detail in coming sessions, right? So every day we are going to pick one of the services. Maybe some services are bigger, right? So say EC2, it's a bigger service. Maybe it can take 2 days or 3 days. Doesn't matter. We will go through each of these in detail. We will get our hands dirty spinning up our servers in the cloud, and we will learn it in detail, right? Then we come to AWS Marketplace. So what is AWS Marketplace, right? So AWS Marketplace is a place where you can sell your products that you have built on top of AWS. Okay, so imagine this scenario. Maybe you are a company who is selling anything. Maybe you are a very specialized stock marketplace. You are selling stocks online. Over time, you develop some kind of expertise in selling stocks, or for that matter, anything. Okay, you have a really nice e-commerce platform similar to Amazon, and you want to sell all that infrastructure that you have built as a template for other businesses to come up online faster. Now, when you are building something new, you have to invest a lot of in good people, right? You want to build the servers, all the software that is running on top of that. And once you have built that, you're using it. But now you want to sell that solution as well, right? You build a marketplace, great, works for you. But say another company, maybe they are selling flowers, or maybe they are selling fruits online, and they want to leverage same kind of functionality. You can put your solution up on AWS Marketplace for some fee. And whenever somebody new wants to use your infrastructure, they can pay you $100, and they can leverage your infrastructure that you have already built in their own AWS environment, right? So you are providing them a software. It's similar to selling a software. Microsoft created Word and they're selling it to whole world, right? Microsoft created Windows and they're selling it to whole world. It's similar to you created an e-commerce site. It's good for you. Now you want to sell it too, right? So anybody can come online and use your software, the code that you have built on top of AWS, the solution that you have built on top of AWS. You spent a huge amount of money. You can run your business off AWS as well. There are few firms. I'll show you AWS Marketplace right now, and you can really see, okay, what I'm talking about. So maybe you want to go to Marketplace. Okay. So if you go to Marketplace and just see here, so you find a breadth of credit. This, you buy it, you deploy it, you manage it, and you just can discover products. So if you go to discover products, there are hundreds and hundreds of products here. So you don't have to build each and every. So Microsoft is selling their Windows server here, right? CentOS is selling their CentOS server here. WordPress is selling their simple WordPress website. Red Hat is selling. Amazon itself is selling specialized use cases here, right? So OpenVPN, if you want to establish a VPN server for, so you all know NordVPN or BetterNet or any VPN provider for say, okay, they are in turn using OpenVPN in the backend. So OpenVPN built a product, they have put it here for selling. Now different companies are utilizing that product and coming up with their own products on top of that. Okay, so say you end up developing a good solution, you can put it out there and companies will buy that product and come up with their own solutions around it. Maybe you want some kind of e-commerce platform. Okay, so there are simple e-commerce platform. So you don't have to set up your whole website, just use one of these and build on top of that. right? So you don't have to code each and everything again. So there are free trials. Some of these are per hour basis. Let me go to a firewall. Okay, each organization has their own firewall. So they see you have Fortinet, you have Palo Alto, you have pfSense, and everyone. So say you want to deploy a Palo Alto firewall. Okay, buying a firewall off the shelf costs you hundreds of dollars, thousands of dollars. So a simple VM series firewall machine from a Palo Alto costs around $8,000, and it's a huge investment for an enterprise, small enterprise, but they want security. So what they can do, they can rent it at $0.192 per hour, right? So if you want a Palo Alto firewall, you are paying $0.129 per hour. So in 10 hours, how much you are paying? Almost $2. Okay, so you don't have to commit to that investment. You can just use this platform and build on top of that, right? So it's not just the servers, the compute, that's the storage that you are getting. You're also getting the software, the specialized use cases on per hour basis, right? So if you want something of the firewall, you can use this. No worries. There are free versions as well. And if you end up developing something of your own, you can sell that as well. So while you are spending on AWS, you can also be earning. Okay. So these are the popular categories. This is how the AWS marketplace looks, right? So whatever service the AWS has, it's right there under the services section, and you can use any one of these services. Now, you don't have to learn all of these, but the basics. If you know the basics, you can build on top of that and really do. Even after working 12 years in cloud for really big companies, I might have used only maybe 40 or 45% of these, right? So some of these cases are very specific. I'll tell you how. Like a satellite ground station. Okay, if I'm not working for a satellite company, I don't need this service. But yes, a third person might be working for a satellite company and he needs this service, right? So quantum technologies. You don't have to have a quantum computer in your organization, but if you want, you can have it. So it's like the power is there, but how much you want of it, how much you want to use it, what are your use cases. So all of these will depend on the use case that you are having. You don't have to use each and every one of these. You don't have to learn each and every one of these, but you have to learn the basic services that I talked about: the servers, the compute, the VPC, the RDS, the S3, the EBS. All right. So this is how AWS looks. This is how the actual infrastructure is. All right. Let's get started. So solution architect associate course. So we'll explore today that what all different certifications AWS offers, what are the prerequisites for achieving each and every certification, and I'll share you certification details. And then I will concentrate more on AWS Solution Architect certification, what is expected in AWS Solution Architect certification, how you can achieve it, and what it will take you to pass that certification successfully and lead a very successful career. We'll also spend some time setting up our AWS account, though I showed you in my previous class how to set up account, but we'll go over it today as well. And maybe you can set up your own account today or maybe tomorrow. And if you find it difficult to set up, reach out to me and we can go from there. So why AWS certification? So it's good to learn AWS. I mean, if you are learning AWS without a certification, it's perfectly fine, right? But certification adds a certain value, what you call it, certain trust for an employer to invest in you. So maybe I'm an employer and I want to hire someone to run my AWS infrastructure for me. I want someone to set up all my servers on AWS. Now, I just put out a flyer or maybe a interview. Okay, I want a guy who can set up my AWS. Initially, I don't care about the certification when I'm just looking to get my work done. But imagine two guys walk in, they're equally good. One has the certification, one don't, right? So certification is AWS has tested you, they have taken your exam, and they say that you match the standard that AWS has set for that particular specialty. So AWS certified person will carry more weight in an interview as opposed to someone who is not certified. But yes, skills matter the most. AWS certification is the next step. You can clear certification even if you are not that skilled, right? So when you are in an interview, they'll ask you a bunch of questions, they'll test your skills, right? If you match those skills, then AWS certified person will carry more weight even if he's matching the skills of a non-certified person. You have to understand that. So it's like going to the gym, right? You can go to the gym, you can do all the exercises that are there, but if you don't follow proper diet, you are not going to get same results, right? So two people going to gym, both working out, one is following proper diet, one is not. The person who is following proper diet will get better results, right? So AWS certification is kind of that diet. You have followed your regime, you know your skill, but you have also followed that diet, you have also done some work, and AWS has certified that, okay, you know this stuff by taking your exam. So as an interviewer, if I find two candidates, maybe you are a bit lacking in some skills, maybe 10 or 15%, you'll carry more weight because you have certification as well. That means AWS has tested you to be good, right? They have taken an exam and you have to pass that, so you're good. So there are three levels to the certification. One is foundational, then comes the associate, and then comes the professional. We went over this as well. Okay, what are the different parts of certification in a previous class, but I'll go over it in detail today. So foundational is like, okay, this is my first class and this is my first time interacting with AWS. I just want to put out there that, okay, I know some of it, but not everything about it, right? Associate is more like a bachelor's degree from a college. You're not a master, but you are qualified, right? So with some experience, you will be a master. Associate is just a bachelor's degree. And being a AWS professional is that you have a master's degree in AWS, right? So foundational is more of doing your high school, right? Associate is more of going to the college, and professional is more of pursuing the master's degree, right? And for professional, I really recommend you that you put a couple of years of experience under your belt and then go for the professional training. Else it's not just worth it, right? But the associate training you can pursue right away. Both foundational and associate training you can pursue right away. But if you can pursue both of these right away, which of these carry more weight, right? Associate training carries more weight than a foundational training. Foundational is very easy. Even like now you don't have that much knowledge about AWS. If I give you a bunch of pages, you'll be able to clear the foundational exam, right? Just go through it, read it, okay, mug it up, and you will be able to pass the foundational exam. Because foundation training exam is not that hard. They don't ask a bunch of stuff. It's just like, okay, I know some of AWS, I'm not sure about it. But yeah, associate training really validates, okay, this person actually knows stuff, right? So the certifications are offered under these categories. One is Cloud Practitioner, which is the foundational training for all these paths. Then you have your architect path, then you have your operations path, then developer path, and then the specialty. So here's how it works. You want to go out there and explain to someone that I know AWS, you have to have architect path, right? Once you have architect path, that means you know all of AWS, you know all of their services, all of their main services that are used on daily basis, that are used like 80-85% of the time. You know, you are expert in that, and you can build solutions around AWS, right? Operations path is, okay, you have built the solution. I have a diagram. I have built a solution. I have a working proof of concept, a smaller environment. Okay, these couple of things are working. I can build other stuff around it, and I can look at day-to-day tasks. You also can look at day-to-day tasks, but a operations person cannot design the solutions, right? Architect person can operate as well as design. Okay, operations guy will only work on it. He cannot design solutions around it, right? Okay, he can work on EC2, the compute service. He will know how to start a server, stop a server, and everything. But a architect will know, okay, where I have to put this server, how big of a server I need, how many servers should be there in each region so that my users are catered well. Maybe I need to attach 100 GB of storage with this. Maybe I need to attach 1 terabyte of storage, 1000 GB of storage with it. That's what architect does. And that values more because the solution that you come up with ultimately is going to affect the costs, right? And if you lower the costs, then only, and increase the performance, then only your solution is a success, right? You can spend $1 million in a day, come up with a solution that just works, but a proper knowledgeable guy will do the same task in maybe $1,000 or so, right? So you are wasting money if you are not expert there, right? So if you are an expert, you can really save money for the enterprise, and enterprise will value you. Okay, this person is saving so much money, that's why they pay you, right? So any job that you work, you are paid in proportion to the value you are creating there. If you're not creating value, you won't be valued that much, right? If you keep creating value for an individual who is running business, he'll value you. Okay, he'll know, okay, this guy has saved me almost $500,000 last year, right? So it's good to pay him rather than someone who's gonna waste maybe a couple of thousands more. That's why the AWS certified solution architects are so much in demand. I just did a small Google search, okay, AWS certified solution architect salary in US. So this is the median salary. And this particular certification is the highest earning certification of all the certifications out there. So there are thousands of certifications out there, be it Microsoft, be it Google, be it anyone, Salesforce. There are so many technologies out there. But this particular certification is valued the most. Just having this certification can take your salary above $100,000 mark, right? So you go at any link, be it Glassdoor, so Glassdoor gives it at $110,000, right? So ZipRecruiter gives it $115,000. So it's right in that ballpark, right? So it is more than $100,000. It's more than $110,000. So even Global Knowledge puts it at $130,000, right? So if you look at these medians, so LinkedIn puts it at $142,000. It's a median salary. It's not the higher end of the market. This is the median salary, right? This is the average a person who has the certification is earning in US right now, right? Why they are earning? Because you are able to deliver value to an enterprise where you are working, right? You can build solutions that really save money for a company, and they are paying you for that privilege to save money, right? So the average salary, I'm not talking about even if you go at the lower end is still $100,000, right? So any enterprise who has you on their staff knows that you are going to bring value to them, right? That's why they are paying. So the next path is operations. So operations guy will just build stuff. There has to be at least one solution guy for an operation guy to start working, because unless and until solution guy gives him a diagram, okay, you have to create stuff like this, operations guy cannot do that because he doesn't have the expertise and the knowledge of how these solutions work together, right? He doesn't know how they are going to talk to each other. He doesn't know how much money should we be spending on a particular service of AWS. He doesn't know how big of a capacity we need, right? So architect comes in first, then the operations guy comes. Now say you are a developer, right? You write code. So your code has to run on AWS now. You go for a developer certification. It's for a programmer. So the person who has a programmer background, who's been coding for last maybe 5 years, he wants to start a career in AWS. He wants his software, whatever he's writing, to run on AWS. And he wants to be aware, okay, what are the services? How can I integrate them into my code? He will go for developer certification. Then comes the specialty. So there are different products in AWS. Some are compute products, some are security products, some are big data products, some are network products, right? So if you want to specialize in a particular area, right? So say you want to specialize in network, right? So you have the basic knowledge of whole of AWS, but you want to really go deep into a particular specialty. This would be like more like doing PhD, doing the doctorate in a particular thing. So at bachelor's level, you study everything. You have a major, but you study a bunch of other stuff as well, right? When you go for master's, you study only that major and maybe your minor that you have declared on your in your bachelor's degree. But when you go for a PhD, you only select one small subset of that major and master it, right? So this is how it works. Architect or operations or developer, they're just bachelor level degrees, right? So if you do an associate, you are just doing bachelor's. You go for professional, you are doing like a master's. And when you go for specialty, you are doing like a PhD in that particular subject. So just to put a hierarchy, I mean, these terms are self-explanatory. You have a specialty, you are a associate you as a professional. But yeah, to put it in general terms, like how it matches with the real world, this is how it compares with the real world. And to graduate with a PhD, it would take you more than 10-15 years of education in a college, quite expensive, right? And if you are very focused in AWS, you can achieve all of these certifications in a couple of years, right? And a PhD guy will be earning, I can guarantee you, almost equal or less than a guy who is very strong at AWS, right? So he has a 15 years of education. You have a couple of years of experience on AWS and you are very good at it. You have done all these certifications, and you are going to do at a cost that is significantly cheaper than a college education, right? College education can set you back thousands of dollars. And maybe all of these certification, if you do each and every certification that is out there for AWS, it will probably cost you $1,000. Every certification that is there, $1,500, you are done with all the certifications. There are 12 or maybe 15 certifications. If you want to do each and every certification, you don't have to do each and every certification, but say if you want to do, right? Just for the cost of one class that a bachelor guy in college is taking, you can become a PhD in AWS. It's cheap when you compare it with the college education rate these days. So these are AWS recommended paths, how you go about taking certifications. So for professionals, they say 2 years. For associate, they say 1 year. And for the foundations, they say 6 months. Now, here's a catch. 1 year of experience solving problems and implementing solutions using AWS Cloud. This is if you don't have any training, you're just learning on your own. You're working as an intern or maybe a freelancer guy somewhere, and you acquire all the knowledge that I am going to deliver in this class via doing work. But if you do good training, if you read about stuff, if you start working on stuff, right? So you can do that 1 year of training, that 1 year of experience-based training in a couple of days. Because what in 1 year, say you are working at a company, there would be some tasks that you do every day, like creating a server, deleting that server, right? Doing that couple of times gives you the expertise. So it's not like rocket science you have to do, it will be different each time, right? It's same process if you do it million times over, right? And if you do it like couple of times, you are done, you are masters in it. So you don't have to wait a year to pursue a certification. Even practicing something for a couple of times can get you at that level. So as we go along this course, we will take one of the topics that is there in the AWS, explore it in detail, do some practicals around it, do some workshop around it, and you will be as good as a guy who has a year of experience in AWS. So you can go out and give your solution architect associate exam. If you look at the side, these are the specialty. Advanced networking. You want to be an expert in network products of AWS. Big data. You want to be an expert in big data products, then security, then Alexa skill builder, then machine learning. All these are specialty, right? So you want to specialize in particular area, particular 2 or 3 products. It's like doing a PhD in 3 products. You know each and everything about them, right? So for day-to-day operations, you don't need that. But yeah, maybe once in a while you come across a scenario where you really have to get very creative, very, integrative in terms of AWS products, then you can go for a specialty guy. So specialty is more for consultants who work on projects for short-term basis. Companies hire them for a small project that they really want somebody very good to help them. But yeah, 90% of the time, a solution architect would be able to do just that. Say you have a very specialized use case, then you need a specialty guy. And maybe you can pursue a specialty. Maybe you want to be a consultant, right? You can pursue a specialty, but only once you have experience, once you have that level of expertise, because specialty level of expertise comes from practice, not from any training. Once you have 3-4 years of working in AWS, maybe you start working in a company that is more focused on security, right? You would be having a huge security domain knowledge. Then you can pursue AWS specialty and maybe become a consultant, right? But these specialties are very, focused, very small percentage of the market. 80-85% of the market is doing solution architect associate. They are asking for solution architect associate. So these are just the suggested prerequisites, as I said. You don't have to adhere to those. These are just AWS recommended without any training. If you don't have any training, you need to have this. But if you have this training in a month as well, you can give associate exam. So like here we have a month or maybe more than a month with us, right? We have around 30, 35, 40 classes But when I go and deliver these trainings for corporates inside their offices, it's just 1 week, maybe 3 or 4 hours a day, and they complete that training within that week and get certified within that week. So it's entirely possible. It's not like, okay, this is rocket science. It's a very, so there are huge words, AWS Solution Architect Associate, this and that. There are a lot of services. As I said yesterday, AWS Elastic Compute Cloud is just servers. It's plain old buying a computer, right? They have fancy names attached to terms, but at the end of the day, at core, they are just normal services that you do use, that you take for granted on everyday basis, right? So this is a path you take. You read about technical essentials, you read about architecting on AWS, you take a exam readiness solution architect associate exam, and then you go for actual certification. These are AWS recommended paths. So how you can find all these paths? You just go to aws.training. So if you go to aws.training, right, this is aws.training website, and maybe you want to learn at your own pace, like, so you can browse some courses. Here are some courses. So he recommends AWS Technical Essentials. There will be something called AWS Cloud Practitioner Essentials. So it's in Spanish. There will be in English as well. You can select from any one of these courses. I'm going to teach you. Don't worry about it. But say you got some free time, right? You want to explore more. You can go to aws.training. Just click on one of these and start learning, right? So once you have the language English selected, you can click on any one of these. aws.training is the website. Just sign in with your Amazon account, normal amazon.com account that you use for shopping, and you can start learning at your own pace. I'm going to teach you each and everything in the class. Say you have a doubt, you have some free time, like you are on a subway, you have a couple of minutes free with you, you have half an hour. Go there, just click on a bunch of stuff. It's very interactive. So maybe I select something, suppose this. So it will just sign in. It's a free course. You don't have to worry about paying about it. And you just sign in with your Amazon account. As soon as you sign in with your Amazon account, you'll be good to go, right? So it will tell you this. So it has some prerequisites, right? So those prerequisites we are going to cover in this class. We are going to go into detail of each and every service. But say you got some free time, you can explore here as well, right? So this path is for AWS Solution Architect Associate. Okay. This is for professional. So for pursuing a professional level certification, you have to have a associate level certification first. You cannot directly jump to AWS Solution Architect Professional. First, you have to give associate exam, right? And then work for a couple of years, and then you can go for AWS Solution Architect Professional exam, right? So it's not like you can directly give that professional exam. You have to have Solution Architect Associate. But cloud certified professional, practitioner is more of an optional thing. You don't have to do that before giving associate exam. You can give associate exam directly after this training. But yes, for a professional exam, you have to have passed the AWS Solution Architect Associate exam first. So this is the format for cloud practitioner certification exam. So you got 90 minutes, about 45 questions, and the cost is $100. You can give it from your home as well. You just have to keep your webcam on. A guy at a remote location will monitor you so that you're not cheating. You'll get multiple questions. Just click on the questions, click next. So questions would be like, let me give you an example of a question. Yeah. Say you want to store data in cloud, and that data needs to be very accessible, very fast to upload and download. Which service are you going to use? So you'll have 4 options. One would be EC2. That is wrong because it is EC2 we use for servers, right? You'll get the hang of it once we start going deep into the services. So second option maybe is RDS. You know, RDS is a relation database store. It's for SQL, the database, not the storage. Maybe third option is EBS. So EBS is server memory, not upload and download memory, right? So the fourth option is simple storage service, S3. So S3 is where you actually upload and download stuff. If you remember from the example I gave yesterday, you want to set up a website with 100 GB of storage attached to it. So the right option is S3. You click on that, you get marks for it, and you move on to next question. So this is how the exam looks like. As we go along, I will keep quoting you for each and every topic that we study, what kind of questions can arise from the topic. And I will also give you some dumps around the exam, like previous questions that have been asked in the exam, that will give you a pretty good idea about it. Okay. So these are the topics that are there. Basic AWS architectural principles, right? What you have to use if you want your site to be redundant, if you want it to be closer to your users, what are value propositions, how you can save money, what are some key use cases of AWS services, like I just asked you. If you want a fast upload and download storage, what you want to use, how you can implement security, what are cloud deployments and operating principles. We're going to study each and every one of these. Don't worry about it. It's just a prerequisite. Okay, these are the topics that you should know to pass the certifications, because if you have 40 questions, maybe you will get 8 questions from each topic, right? So this is how it works. So if you go for solution architect associate, so it's 130 minutes, 45 to 60 questions depending upon the question type. So maybe if you get easy questions, they'll bump up the question number for you. If you get some difficult question, they will reduce the question numbers for you. And it's usually 45 questions. So you get 2 minutes, almost 2 minutes for each question, 2.5 minutes for each question to attempt. So when I gave this exam, I was done in an hour. So I had 130 minutes. It's very easy. Questions are a bit confusing, yes, but you can really breeze through it if your concepts are clear. You can easily do it in an hour. They have given 2 hours and 10 minutes. You can easily do it in an hour if your concepts are clear. Some questions are tricky, I agree, but it's not that difficult. So the topics are AWS network technologies, how you set up your network, right? AWS applications and client interfacing, how you interact with your applications, right? If you want to interact with the server, how will you do that? If you interact with the storage, how will you do that, right? Security and reliability. You want your AWS to be secure. How you go about creating passwords, creating users and everything. How you set up a hybrid cloud. Maybe you want to connect AWS to your current data center, because you will get this a lot. An enterprise you are working, they already have invested in a data center there in their backyard, and now they don't want to go out and purchase more servers, but instead whatever new application is coming, they want to put it on cloud, right? And those applications that they're putting on cloud has to work with the applications that they have running on their current data center, because they have already invested in it like 15-20 years ago. They're not going to throw away that money, right? If something better comes along, you just don't throw away things that you have, try to reuse them, right? So if you have a current data center, how will you connect AWS to it? We'll learn about it. High availability and scalability solution, how you going to scale. Say you currently you serve 100 users, maybe you want to serve 1,000 users, maybe you want to serve 10,000 or 1,000 users. How you go about doing that? How you can ensure data security, how you can ensure disaster recovery. So if you think about it, the example I gave yesterday, okay, you want to set up a website on your soil, right? With it being highly scalable, very fast. I covered each one of these. Disaster recovery, yes, because even we are in multiple regions. So I had set up my website in a couple of regions. Even if one complete region, 3 data centers are going down, my other region is up and running, right? Because my website is scattered all over US, right? Scalability. We can set up servers very close to the user because it's distributed all over the US. Okay, it's scalable. Highly available, yes, because even if one data center is going down, I have my website running in other data center. Data security, yes, because I have passwords and everything around it, right? So these all were covered in my example yesterday. So that's how it works. Each and every solution that you create as a solution architect has to account for all these things. And as we go along this course, you will really learn how we can go about doing that. So this is for the professional exam. So professional exam is 170 minutes. It's very expensive, but you will be working as a AWS professional for 2 years now. I'm sure you would be able to afford way more than that. It's a 300 USD. It just asks best practices. So best practices you get acquire only when you are doing stuff. You cannot learn best practices by reading bunch of things. Best practices are like what works and what don't, and that you only acquire by working on AWS, by acquiring some experience. And maybe if you are doing good work, you can clear AWS professional 6 months or in a year rather than waiting 2 years. If you have done enough work, because you will having that level of experience. Migration of applications to the cloud. From current data center, how you take application running in your current data center to the cloud. And cost optimization. Say your solution architect has set up, associate level person has set up something, and you want to optimize cost more. It's an optimized solution, but yeah, as you have experience, you know what works, what doesn't. You can reduce those costs as well. So AWS solution architect candidates needs to be familiar with following AWS services at the minimum. So these services are the basic services that you are going to be using almost 95% of the time. Maybe 5% there comes the niche use case where you have to select some other service. But these services, the compute, the storage, the networking, the security, the governance, the database, and the applications, these are the services that we are going to be using 80, 85, maybe 95% of the time, right? So we are going to study each one of these. Don't worry about it as we go along this course. All these services and more are covered in this course, right? We will take one of these every day, just one of these. And maybe if you are not clear, I am happy to spend another day on same service to clear your doubts and everything. And we are going to take each service every day and work on it. Some services are really very simple and really very small in that. So maybe we can do a couple of services in a day. But yes, the important services, I know which services are important and I'm going to spend a healthy amount of time doing that. So in compute, I have my regular EC2, that is my server. Lambda is more of a programmatic way of doing things. So it's kind of an API. And EBS is my storage for that server. Load balancing is when I want multiple servers just working together. They're sharing the load. And Beanstalk is, okay, I don't want to manage everything. Let AWS manage it, but I will tell them, okay, how much capacity I want, right? So Beanstalk works like that. You, instead of telling AWS how many servers you need, you just tell how many users you have, right? So AWS will automatically spin up the required number of servers for you, right? So not everyone who is coming to AWS is an expert. Not everyone has access to these trainings, these materials and everything, right? But still AWS wants you to be able to use their services. So what they have done, they have built a small automation around it, wherein you just tell, okay, I am expecting 5,000 users on my website on my first day. How many servers should I need, right? So they'll tell, okay, let me figure that out, and they'll spin up the required number of servers for you and charge you only for that. Okay, so it is kind of a solution architecting done by AWS for you. But yes, to talk to Beanstalk, you have to learn a few things. It's not just some magic thing. Okay, I just tell you 5,000 user and it will just do that for you. You have to build your solution around it, right? Then you go for storage. You have your S3, that is your normal upload and download. You have Redshift for analytics, storage replay. So don't worry about all these terms right now, because we are going to study each and everything in detail, right? I'm just putting it out there. Okay, these are the services that we have to study and we will study over next few days. I'm just putting it out there, right? So don't worry if you don't understand what it is. These are just fancy terms for really simple things, right? EC2 is just a server. S3 is just storage. Like VPC is just a network. So all these are really very simple things, but yeah, they have like gave fancy names to them. That's it. So AWS installation and setup. So how you go about setting up your AWS account? It's very simple. You go to Google, just search AWS. You did a search for AWS, search result comes up. Click on the first link that is there. You clicked on the first link itself. You will be taken to this page, right? Click on create account. Clicked on create account. You will be taken to this page. Put your email ID, password, confirm your password and AWS account name. Okay, just like we did yesterday. Any email ID. I'm just putting some random email ID. You have to select a password that satisfies this requirement. A capital case, a small case, a number, an alphanumeric symbol. Okay, my password satisfies that. I have to retype that again. All right, maybe it's a GG. Click continue. And then they'll ask, is it a professional account that you're building for a company or yourself? You click personal. Give your name, your phone number, your address and everything, and just click on create account, right? Once you do, you'll be asked for your credit card information. Don't worry about it. They're just going to deduct some money and they'll return that money. It's not like even if they're deducting $1, they'll return that dollar to you. Okay. It will be returned in a couple of days. Don't worry about it. They are just verifying, okay, your payment method works. And as soon as you sign up, you will get access to their free trial. Okay. So I think I have set it up. Yep. So you'll be taken to this console, right? So once you are on this console, just click on services and you have access to all your services. So how you know in which region you are working, it's right here, right? This is the region list. So whatever region you select, say I select US East 1, Northern Virginia. right? Once I select it, I'm in Northern Virginia now. So if I go out there and create a EC2 server, click on EC2, I go to my running instances. It's currently 0 because I haven't created anything. Just click on launch instance. Once you click on launch instance, it will just guide you to a bunch of stuff. Don't worry about it. We are going to get to it. Just this is the way it is done. So when I create a server from here, it will be created in Northern Virginia, the region that you have selected up there. Maybe you want to spin something up in Oregon. Just click on Oregon. You'll be taken to the Oregon website. Once you're in Oregon, same thing. Click on services, go to EC2, and you will be taken to EC2 Management Console of Oregon, right? We were in Virginia, now we are in Oregon. Maybe I want it in Northern California. Don't worry about it. Click on Northern California. Once you click on Northern California, here you are in Northern California. You can spin your servers in Northern California. So it's just a few clicks away. I mean, imagine doing this without AWS. Like here you have 4 of your AWS, 4 regions in US, on US continent. You can click anywhere and just imagine doing this in a traditional scenario, right? You are an enterprise who wants to build their own data center at these 4 places. You'll have to talk to their governments, the local governments there. You have to select a space, you have to buy that space, then you have to begin construction. Then after doing construction, you have to hire people at all these places. You have to train them at your central location, then send them out there, working there. Then you have to put security there. You have to get redundant power at all these locations. So imagine the scale of it. A small business cannot do that, right? A small business who just has a couple of users, maybe 100 users, 1,000 users, you cannot do that. Maybe a huge corporation like maybe General Motors can do that, right? But if you are a small user, you cannot do that. So Amazon is taking care of that because they have that scale, they're building that, and they are just doing it for you. And you can leverage those services by accessing AWS, right? So these are all, so maybe you want to expand to Asia. These are all the Asia regions that you have. Click on any one of those and you are there and you can spin your, maybe you want to move to Canada. You want your business in Canada. Don't worry about it. Go to Canada. Just click on Canada. You are in Canada region. Spin up your servers there and your Canada users will be using that capacity in no time. Maybe you want to expand to Europe. Maybe you want to expand to South America, right? Maybe you want to set up your business in Middle East. You can run a true global enterprise by just clicking around, right? So whatever region you want to be in, wherever you want to be in, just click one of those and you will be able to just go there and do a bunch of stuff. So right now I am in Northern California. So how I know that it's darker, I've selected that. If I click on Northern Virginia, it will get selected, right? So if I want to go to Origin, it will be selected. If I want to go to Asia, no multiple hoops, just a click away. Let's click on Asia and I am directed to Asia, right? I'm in Singapore right now. If I spin up a server, it will come up in Singapore. I'm in US and I'm spinning a server in Singapore. Imagine doing that without AWS. You have to travel to Singapore. It's a long 20-hour flight. You have to stay there, talk to the government, buy land there. After acquiring land, you have to begin construction. You have to coordinate that construction from US. Huge task, very expensive. But with AWS, it's just a few clicks away, right? And maybe I want to use another service. I had selected EC2. Maybe I want to select S3. Just click on S3. As soon as I click on S3, I'll be taken to S3. Very intuitive, very good user interface. It's not like a lot of clutter is there, right? You want to create a bucket, just click on create bucket. And it's very easy. Just put a name, next, select a bunch of, so I'll tell you what options to select once you start working with S3, what each one of these does. But they have given very good references here. Keep all versions of a bucket in the same bucket. Plain English. Maybe you want more information about it, right? You are not sure. Just click on learn more. It will take you the docs section that I explained yesterday and give you a very nice detailed article around what that option does for you, right? So it's not like, okay, you have to know everything beforehand and then only you can create. Maybe while you are creating something, you can learn about it. Maybe you want server access logging. Just click on learn more. Okay, I want to learn more about it. I want to dig deep into it. Here is my server access login. Maybe you want to learn more about tags. Just click on learn more, right? So each and every one of these options you can learn more about, right? So see, it's a good explanation. Each option comes with explanation. Okay, if you're selecting this button, what it will do for you, right? But say this information is not enough for you, just click on learn more and it will take you there. Okay, so all this like comes with really nice documentation. Say on top as well, see, we have put a very nice explanation. They have, you don't have any how to get started, how you can get started. So right on this page as well, they have put a bunch of documentation. So maybe you want to learn about the console, they'll show you a video about the console. You want to more information, introduction to the new Amazon S3 console, right? So it comes with all the user manuals and everything with it. Another way to interact. So this is the management console, right? Nice graphic user interface. You are interacting with it. You can also interact with CLI, command line interface. You can type a bunch of commands on your machine, right? So what's the advantage of CLI? Let me give you an example. Say you want to create a server, right? If you do it via management console, maybe it's 10 clicks, but for creating 1,000 servers, you have to click 10 times. That means it's 100,000 clicks, and 100,000 clicks is no easy task, right? You are gonna make mistakes. Imagine you have to do as a solution architect 100,000 clicks. You can't do that, right? And if you are going to do it, it take huge amounts of time. So what AWS provides is a very nice command line utility, right? You take a command, you customize it according to you, write the command, and just copy paste it multiple times, right? And you can just run a loop through it. Okay, run this command 1,000 times or 10,000 times. It will just run 10,000 times and just create 10,000 servers for you. It's way easier that way. You have to write the command once and it will run for 10,000 times. But if you are doing clicks on the console, so this is my console, say I have to create S3 buckets and I have to create 1,000 of buckets. So I have to click this create bucket button 1,000 times. But if you have the command, you have to write the command once and just paste that command 1,000 times. It's a way easier task, right? So that's what the CLI gives me, the power to do it faster. And then is AWS SDK, Software Development Kit for AWS. So as the AWS solution architect, you have to know first two of these. You don't have to learn the third, but yes, it's there. Okay, so AWS SDK is for developers, okay, the people who are writing softwares and they want to interact with AWS via their software, right? So then the AWS SDK comes handy. Okay, so this is your AWS account sign up page. Just sign in. I already showed you this, how it works. AWS CLI. So AWS CLI is very easy. It's free to use. You just Google, I want AWS CLI. Click on there. It will show you where you can find. Click on AWS command line interface. Okay, so there are a bunch of ways to do that. Either you have to run Windows or you have to run Mac or Linux. So I'm sure you'll be running one of these, either Windows or Mac or Linux. If you're running Windows, run 64 or 32-bit Windows installer. Just click on this, it will download a file for you and you'll be able to do that. And if you're on Mac or Linux, you just have to write this command in your terminal. Okay, so say I'm on a Mac and let me run this. So I select terminal. Yeah, I just write pip. What was the command? Install, just copy it. Let's paste it here. So it's saying pip install CLI not found. So why is saying that? Because it requires Python first, right? So first you have to install Python. Click on Python. It will take you the Python website, right? Once you are on Python website, this is for Linux as well as Mac. So latest version. So you're on Mac OS, right? Click on Mac OS and you have to download this. So 64-bit installer, click on this, click on allow. It will download a file for you, right? Once it's downloaded, install it. As soon as you install it, then you will be able to run this command. Okay, because AWS CLI requires Python 2.6.5 or higher. So this is the latest Python that you are getting here. Just click on it and it will install that for you. All right. So I don't have to do that. And once you are done with Python, just do pip install AWS CLI and you are done. So how to use it, we will explore it as we go along. I have a couple of sessions reserved just for AWS CLI. We'll explore it in detail, but this is just to put it out there. And then AWS SDKs. So SDKs we have for different languages, different programming languages. We have for C++, Go, Java, JavaScript, .NET, Node.js, PHP, Python, Ruby. We have our SDKs available for these languages. You don't have to worry about it. You are not a software engineer, right? But if you know a software engineer who wants to interact with AWS, just point them to this URL, github.com/AWS samples, right? So if you go here, it will take you here, and these are all the SDK examples we have. So these are for developers, the coders who are going to code stuff. You are going to interact with AWS via their code. Do not worry about it. So what we learned today? We learned today Amazon makes available a number of certifications and learning part to validate your skills, right? So they're validating. So if you give a AWS certification exam, they're validating, okay, you know AWS, okay? And there are 3 levels. Entry level, that is practitioner, mid level, that is associate, and senior level is professional. So practitioner is more of like doing high school. Associate is more like doing your bachelor's degree, and professional is like doing your master's. And then you have your specialty certifications that are like doing the PhD in a particular subject, right? And solution architecting is relevant to those individuals who are working on architecting and designing AWS solution. So if you are going to be working on AWS, if you want to design solutions around AWS, you have to have a solution architect track. And AWS provides a number of mechanisms for interfacing with the services. One is management console, that is that nice web URL that we get, aws.amazon.com. Then I have the CLI, my command line interface, and then I have my software development kit for interacting via code. So you have to be aware of first 2 of these, management console and CLI. So here's something that I wanted to share with you guys. If you go to YouTube and just search Amazon AWS, right? So you will get this channel, Amazon Web Services channel, right? Just click on it. You'll be taken here on this Amazon Web Services official YouTube page, right? This is not some trainer or anything or some guy out there. This is actual Amazon, right? So now you want to learn about something, right? Maybe you want to dig deep into some product. Maybe you want to dig deep into EC2. Just type EC2 here on this search, not the search verb, the search that is there in the channel. Click on EC2, click enter. You will be presented huge amounts of videos that Amazon itself has put out for people like us to clear our concepts around. I'm going to teach you each and every one of these. Don't worry about it. But say you got some free time, you want to learn more about it. You can also learn this through these videos. Just click on one of these. Maybe you have 5 minutes. So each of these videos, so there are very long ones and as well. There are a couple of videos that are 50, 55 minutes. You don't have to worry about those. Just select a few that like this. This is a 2 minutes video, right? This is again a 2 minutes video. How assign a static host name into a private EC2 instance. Just a 2 minute video, right? And you learn a good thing that is asked in an interview that you are going to use. So it's just a 2 minute video. So kickstart for SQL Server 27. This is just a 7 or 8 minute video. You can watch this video while you are, commuting or while you have a couple of minutes free. Just spend 5 minutes on you and watch one of these videos and you'll learn something very good. Okay. And if you have a trip or something and you want to learn more, you can even watch this full scale videos. So these AWS reInvent videos. So AWS hosts a conference every year for their employees and the people who know AWS for industry, where they introduce their products for the first time. So this is them introducing AWS EC2. So this is a foundation level video for EC2 at a global conference that is available free for you to watch. Maybe you have an hour on a weekend, just spin up one of these videos and you will learn something really good. Okay, you don't have to go deep into it, but yes, if you want something, it is out there and you can learn from it as well. So my goal is to provide you with the most amount of materials, documentation, the links. I'm going to give you practice labs where you can go on a website. They'll guide you. Okay, click here, click there. So you can learn building stuff with a guide around you. Okay, I'm going to build stuff in front of you. But yes, when you are watching this webcast, as I'm delivering you, it's difficult to follow along at a same pace because it's your first time. I've been doing this for long. But yeah, these web videos are also available to you as recorded sessions. If you miss something, if you are doing it at your own pace, just go and watch that video, download that video from your LMS, watch that video again, and you will get a really good sense of it. And then try following it. Okay. So as I'm doing stuff in the class, don't try to, okay, I am going to do it right with you, because that will confuse you, because I'll be explaining a lot of stuff. And if you concentrate on just following, just replicating my steps, you will miss a huge amount, right? I'll be showing you each and everything. Watch it in the class, take your notes, and then when my session is done, try doing this on your own, right? So like today I created a AWS account, right? As soon as the class is over, maybe tomorrow you have time before this class, go out there and try creating an account, and then tell me how was your experience, right? If you faced any difficulties. Okay, sounds good. All right then. AWS identity and access management. So what we are going to do today is we are going to create a bunch of accounts. So say you have created one AWS account, right? And here's how it works. Maybe you are an admin, you are a solution architect, you are designing a solution for an enterprise. Now in enterprise, there are tens and thousands of users, right? And each person has their own requirement regarding the access requirements, or maybe in terms of usage they are allowed. Okay, so each and every participant, each and every user, each and every person might require a different level of access. So how you go about managing that access? So whenever you go to a shop or anything, or maybe you are visiting a bank, you are visiting a government facility, your ID card more or less allows you to enter certain areas. So if you're not allowed to enter there, that area is restricted for you. How's that decided? That is decided with the ID card that you are given, the ID that you have, your name, maybe your face, maybe they have your fingerprint on record. So they create an identity for you, right? And based on that identity, like who you are, based on that identity, your access is managed, right? So maybe you walk into a bank, right? Very simple scenario. To the common checkers area, to the where all the cashiers are, everybody is allowed access there, right? You can go there, submit your money, you can withdraw some money, no worries. But can each and every person access the lockers? No. The lockers are accessible to only those who have a locker account there, who have a locker there. Similarly, not every person is allowed to access the vault. The vault will be accessible to the bank employees who only have pre-authorization to go into vault to get money or to get stuff that is there in the vault. So based on their identity, their access is defined. Your identity is you are a customer of a bank, and that allows you to be in checkers area. And maybe some other person, maybe a bank employee, is allowed to go into vault because his identity has the access to go into vault. Similarly, in case of AWS, when you create a user, you're creating an identity, and that user is given some level of access. It can be full access. Full access is still access, right? It can be just access to create servers. It can be just access to create storage or something like that. It can be access to just audit things. So he won't be able to create things, but he will be able to see things that are already created. That allows him to audit. So maybe government comes to you and they want to audit your AWS account. You don't have to give them full access. Just give them an audit access. That's it. So today, this is the course plan that we are going to follow. I'll be introducing you to IAM. Then I'll be introducing to you the various resources that are part of IAM: user, group, roles, permissions, and policy. Then I'll go to access management. And at the end, before jumping into actual AWS resources that cost money, I'll be creating a billing alarm for you guys, so that if ever you cross a limit, you get charging, you get an email from AWS, okay, you are getting charged now, please terminate this, so you know you don't get any surprise bills, right? So IAM is completely free to use. No matter how many users, hundreds, thousands, or maybe billions of users you create on AWS, they are not going to charge you. The chargeable resources are those which actually incur any costs. to AWS. So IAM is more of a free offering wherein you can create one account, and within that account you can have 10, 20, 50, how many users you want. So we will create some users. I'll show you how the permissions are assigned, how the access is managed. All right. So why do you want to create users? As I said in the bank example, each and every person has different set of requirements when they are accessing any system, right? So bank is also a system. Similarly, AWS is also a system. So when 10 users are in your organizations, maybe 2 of them are from your sysadmins, right? A few users are those users who need access to storage. Maybe few users are just your accounts people. They want to keep track of costs that you are incurring. Maybe a couple of people are like, okay, they want access to just database or something, right? So the person who is responsible for servers should not have access to other things, maybe billing, right? So in billing, your credit card data is there. You don't want each and every person to be, accessing your credit card data, right? Correct? So you don't want a person who is responsible for your servers accessing your credit card information, right? So you can create a new user, give them access to all the server access he needs, but don't give them access around the credit card information. So that is a use case, right? It enables secure access. By creating the users and the groups, you can really manage the access, and you will be sure to some extent that your access won't be misused, your account won't be misused, because you have given access to only those people who actually require those, and they gonna use it as per their permissions, right? So this is a workflow how a IAM user is created. I'll show you the screenshots first, but then we will actually jump into console and create some, right? So this is your console, you're aware about it. You go to identity and access management. On the dashboard, this is how your dashboard looks like, right? So when you have created a new account, like I recommend you all create an account. So this is how your dashboard will look like. Initially, every account comes with one user that is called root user. So when you create an account, you will be assigned root permissions for that. All right. So root user has complete access. Any access you name it, he has that, be it your billing, be it your servers, be it your storage, be it your database, everything can be controlled via root account, right? And from a security standpoint, it's not recommended to carry all the tasks with your root account. I'll tell you why. Say you have a root account, right? And you are using that account on daily basis. Now what happens? Somebody manages to hack into your root account, right? You went to a library, you logged in with your root account there. Now the next person who sat on that computer has full access to your AWS account. Wrong scenario, should not happen, because now he can actually control that account, take over that account. But remember, your credit card is added to that account. So he can go on spinning as many resources he wants, and you will be charged for that, right? So whenever you create a AWS account, go to AWS, create a new user with almost full privileges like we will do now. So if and ever you forget your that AWS account logged somewhere, you can just delete that user rather than changing your whole root account, right? So how you go about creating users, you just click on add user, name of users, what kind of access do you want to provide them, then you click on next, you add permissions. Just breeze through these slides. We'll go into detail of each one of these as I will create the users in the console in front of you. Once you have added permissions, click create user, and your user will be created. Now let me go to console and just create this user for you, right? So this is my AWS management console. Okay, I go to services, just type IAM. Okay, I typed IAM. Okay, so click on users, either from here or here. I'll click from here. So right now there are no users. All right, click on add user, this blue button here. You clicked on add user. What would be this user's name? Maybe user one. Anything, you can give anything. Now the access type. There are two access types here. One is programmatic access and another one is AWS Management Console access. Now, what is the difference between these two? When you want a user to be able to see this console like you are doing it, you want to give AWS Management Console access. All right. And when you want user to be able to access this AWS via CLI. Remember in last class, I told you about CLI and SDK. If you want them to be able to access CLI and SDK, see, they have written it, AWS API, CLI, SDK, and other development tools. Then you want to give programmatic access. Okay, so right now I don't want to give the programmatic access. I just want to give management console access. No worries. Now next comes the console password. What password they should put in when they are trying to log in to the account. You can give your own password, a custom password, or you can have AWS auto generate that for you. So when you click on auto generate, the user will get it in the, you will see that password one time. You can copy it, email it to user, whatever. You can have him sitting by your side. He can note down, he can remember that password. So when he logs in the next time, he will have to create a new password. So I'm going with a custom password. I'll give a small password, right? So now you have given one password. See this, require password reset. So you have created user. Now, right now, you as well as that user both know the password. But when that user will try to log in for the first time, AWS will ask him to change your password. So that way, you are admin, right? You should not know other people's password, right? A person should be responsible for his own password. You should not have access to other person's password, even if you are an admin, right? So this is the password. We'll see if AWS asks me for my password when I log in or not. Next, I'm going to give permissions. Okay. So there are two ways to give permissions. One is by creating groups. We are not going to do that right now, but up in the when we create next user, I will do that. And second is attach existing policies directly. Okay. So there are three options. Either you add him to the group, or you copy the permission from an existing user, or you attach the policies directly. We don't have any other users. We don't have any group. So my third option is attach existing policies directly. So which kind of thing I want him to get access to? Maybe I want to give him access to EC2, that is my compute, right? So I type in EC2. So you see this Amazon EC2 full access, right? So if I click here, he will be able to access all of EC2. EC2 is this service. So, okay. So say I want to give him access to only this service. Just click on that policy and he will have access to EC2 only. Now, maybe you want to give access to S3 as well. Okay. See this policy? You will have access to S3 as well. So all these products that you see here have one policy each. You can give access to all of them. You can give access to only one of those. You can give access to 10 of those. It's your choice. So I gave access to EC3. Next is tags. Tags are just a way to organize your users. So department, for example, say this person belongs to sysadmins. Maybe tomorrow I have a department named finance. I can create one for finance. I can create one, say marketing, and so on. Next, when I click review, it will tell me what I'm going to do. So I'm creating user one who will be having AWS Management Console access. The password type was custom because I added it. Require password reset. When users logs in for the first time, they'll ask him to reset his password. Permission boundary is not set. And what kind of permissions I have given him? I have given him EC2, S3, as well as able to change his own password, right? And what are the tags? I have given a tag named department whose values is sysadmin. As soon as I create user, my user will be created. Now, when a user wants to sign in, he has to go to this link. All right. Now I'll show you how. And you can also send an email to that user from here. Maybe they have an email ID. Just click on send email and email will open. You can set up your email and a mail will be sent to him. Right. So right now we are going to test if that user works or not. So I copied this. Let me go to a different browser. We paste it here. Click on enter. So this page will open for me. All right. So the user was user1, right? Enter his password. Click on sign in. Not now. See, now he's asking me to change my password because this is the first time I'm logging in. So let me change my password. Right. Confirm password change, not now. And I am logged in as user1. Come on. See, user1. And this number is your account number. So every AWS account has a unique account number. This number is this 12-digit number is your account number, the account that you are working on. Now, let's see if he has the required access or not. I wanted him to access EC2. Let's click on EC2. He is able to get here, right? He can see everything. And maybe he wants to go to instance. We'll go to EC2, don't worry about it. I'll explain EC2 in detail when we reach EC2 lesson, but just for now, he can do this, like all access is there. Okay. Now for S3, he has access. Let's see. Okay. So S3 as well, he has access. He's getting all the details there. Now maybe look at something that we didn't give him access to, maybe RDS. Let's go to RDS, see what happens. Okay, so he's reaching till here. Go to DB instances. See, he's getting an error. What's the error? User1 is not authorized to perform RDS DBS cluster. So he's not able to even view. There he was able to click and everything and do everything. Here he is not even able to, so he'll get a error right away when he tries to do anything in RDS. Right? Maybe some other product we want to test. Maybe go to VPC, right? Network access. He has access to network or not. Let's click on your VPCs. Okay, till here he has access. Let's say if he tries to create one VPC. Okay, so he tries to create. Okay, now he is able to create this, right? Why is that? We didn't give him access to VPC, but still he is able to create this VPC. The reason is because we have given him access to EC2. EC2 is just servers. Servers required network to function, and VPC is network in AWS world. If we don't give him access to VPC as well, he won't be able to spin up any server. So even if you have specified just the EC2 there, he still gets access to VPC because VPC is in turn required by EC2 to function. All right. So if you give access to VPC just, okay, now we are going to do it in reverse. We will give access to VPC, but won't give access to EC2. And let's see how that turns out, right? So let me go back. Let me just go to IAM and edit his access. So I have one user now. Click on this user whenever you want to edit it. And just remove EC2 full access policy. Come on. So whatever access you are giving, you can actually view it here, S3 full access and so on. Let's come. See, an error occurred when you are not authorized to perform this operation. So as soon as you removed that permission from as user, you're getting an error. If I go to dashboard again, if I go to running instance, again, I will get an error. Maybe if I try to launch an instance, it will let me go till the end, right? But still, you're not authorized to perform this operation. You will get errors. All right. So with AWS, you can really have very granular control over what your users are allowed and not allowed to do. See, we removed the EC2 access. Now I'm getting retry. I'm getting errors all over because VPC access was coming because I had given him EC2 access, because a server requires network to connect. All right. But now I have removed that access. Now he's not able to access the VPC. Don't worry about VPC. Don't worry about EC2. Just concentrate on the permission for now, because these all topics will have their own classes, 2 or 3 classes each topic. Don't concentrate. I'm just explaining how permissions work. All right. So click on add user. Name of the user is user2. All right. AWS management console access we want to give. Okay. We want to give him a custom password. Let's give him a custom password. All right. Then I want him to reset his own password when he tries to log in, because I don't want to know his password. Click on next. Okay. Now, do I want to add him to a group? No, I don't have any groups right now. I'll create groups later. Do I want to copy permissions? I can, but let's not do that and give him permissions directly. I came to permissions directory. All right. What kind of permission I want to give him? I want to give him permission to create EC2. All right. So search for EC2 full access somewhere here. This is EC2 full access. Okay. I selected that. Okay. Maybe you want to throw in another permission, maybe VPC permissions. VPC full access. No worry about it. Maybe I want to throw in S3 as well. Whatever product you want. Maybe I want to throw in RDS as well. Any number of permissions you can give. You can mix and match. Click on next. I want to add tag. So my tag is keywords department. Maybe this person is from admins. All right. Create user. This is my summary. Okay. User 2, blah, blah, blah. These are the permissions. Create user. User is created. All right. Now let's copy this URL. This URL will be same for each and every user. Go back here, log him out, the previous user that we are running, sign out. All right. And just paste the URL here, click on enter. We will get a simple sign in console. All right. So I want to log in with user 2. All right. What's his password? Okay. This is his password. Click on sign in. Not now. Ask me to change the password on first login. I'll do that. Change password. I change the password, and I am logged in as user 2. Right. So the additional permission that we have given now is RDS. Right. These 3 were already there. So let's go on RDS. And last time it threw an error as soon as we tried to see DB instances, right? Let's see if it throws an error now. No, it's not throwing any error. It's just saying no instance found because we don't have any instance. Last time it was just giving me an error. You are not authorized to view instances or not, right? So you have your user. Maybe I want to remove these permissions from this user. Don't worry about it. Go to IAM again. Okay. IAM users. Now I have two users. I want to edit user 2. I want to remove his permission for RDS. Okay, we can do that. Just click on this small cross here. As soon as I detach it, right? So now he'll no longer have access to RDS. Let's verify that. As soon as I click on databases, see, got an error instantly. You don't have access now because you removed that permission. Okay. So when you create users on your own, you will get really the hang of it. But right now, okay, the process is this. I'm just showing you the process. It's like, okay, this is a car and this is your gas, this is your brake, this is your clutch. But unless and until you sit on driving seat, take the handle in your hand, take the wheel in your hand, you are not going to, you won't be able to steer it, right? So when you view these videos again, try to drive that car, you will get a real hang of it. Okay. Now let's go and create a group. Okay. Let me create a group, create new group. So maybe the group's name is SYS admins. So all my sysadmins will stay in this group. Now, the advantage with this group is when I'm creating users, I have to add policies every time, right? But if I create a group, right, and I add policies to that group, so next time I create a user, I just have to add that user into that group and he will automatically get those policies. Okay, I want to create a group that has EC2 full access. Okay, don't worry about it. Okay, created this and this group is created. Okay, now I have a sysadmins group. No users are there, but I have a permission to have EC2 full access. Now I go to users, I click on add user, user 3. Okay, AWS management console access, construct password, blah, blah, blah. And I created this. Now what I want to do, I want to add policies, copy existing. Now I have the option to add from group. As soon as I click here and SYS admins, my user is created. That's it. So if I go to IAM now and look at my users, so see this user 3 is now part of sysadmins and he will have all the permissions that sysadmin groups carry. So what are those permissions? Those permissions are EC2 full access. He has one permission of his own, that is to change his own password. Another one is EC2 full access. That is attached from the group. So this is the way how you can inherit policies. So maybe you want to create an audit user. So what audit people do? They should be able to see everything, but not create anything, right? That's how audit works. They come, they see, okay, these are your records. They are fine. So let's create an audit group wherein we give them read-only access. They can only see. So create a new group. The group's name is audit. And I click on, so say I want to give them EC2. So here is EC2 full access. Here is EC2 read-only access, right? So full access gives them creation as well as read, everything. Now, when I click on read-only, they'll be able to see what is in there, but they won't be able to create anything. Okay, so they won't be able to spin up new resources, new servers. Yeah, audit is there. Okay, I want another user added to this group. Which user? I can add all of them. So a user can be member of multiple groups as well, right? So say I want user 1 to be part of audit group. Okay, don't worry about it. There it is. So if I go to users, see, he's part of audit now. And if I see his permissions, so he had S3 as well as password change as his own permissions, but now he is also getting the audit permissions from audit group, which is EC2 read-only access. So you can mix and match around these. Okay, now let's go back to our PPT. Now we created users, we created group. Now, there is another way to manage permissions, and that is role. Now, you ask me, okay, group is also sort of right role, right? There is an audit role, there is a sysadmin role. But these are for your one AWS resource talking to other AWS resource. I'll tell you what I mean by that. Say you have a server, right? You created a server. Now you want that server to be able to upload data to S3. Okay, your server should be able to talk to S3. Okay, now if you enable S3 to be, accessible from everywhere, what that causes? Any person who logs into your server has automatically access to your S3 as well. So say in case of a security breach, you lose one server and with that goes your S3 as a part of it. But if you have created a role, if you have trust policies, you can restrict that access for AWS as well. So even a person is logged in your AWS account, he is logged into your server, he won't be able to access other resources because you have not given them permissions to do that. Okay. And creating a role is as simple as creating a user or creating a group. So let me go back to my console. See, here's your role. Click on role. So it will tell you what a role does. Okay. A role is a secure way to grant permissions to the entities you trust. So what are entities here? Maybe an EC2 instance. Maybe your AWS service wants to talk to another AWS service. Maybe you want your corporate data center to be able to talk with your AWS, right? Just some fancy terms, but have really simple meanings. So let's create a role. So maybe you want your one EC2 instance that is handling your user data to be able to talk to another AWS service. So see, common use case EC2. Let's create EC2. Allows EC2 instance to call. Okay. Click on next. So what kind of policy you want to give him? I want him to be able to access S3. But I don't want full access. I want him to give only read-only access. Right? So when you click on next, maybe we can skip the key for now. So here is the role name. EC2 server can access S3. Okay. Allows EC2 instance to call his service on behalf. Correct. And click on create. As soon as I create it, I have this S3 EC2. Where we will use it? We will use it when we create EC2. Right now, just learn, okay, this is how it's created. And you can create a number of roles there. Don't worry about it. Similarly, I have policies. So what are policies? See, EC2 full access. It's a policy which gives permissions. So policies are way to manage permissions. You want 10 permissions, you want 20 permissions, you want permission to S3, you want permission to EC2. So right now it might seem a bit, scary or intimidating, but it's very simple. All the policies that you need are available here. And if you want to read about them in detail, just click on one of those and it will tell you, okay, full access, full access, full access, full access, full access, right? So you don't have to worry about, creating policies or anything, but you should know, okay, these are the options that are available to me. I can have a user select any one of these 200 plus policies that Amazon has already provided me. I can give ES full access. You can have read-only access. You can have really granular control over your AWS account. Okay. So main thing that you want to know about IAM is how to create users, how to create groups, and how to give them permissions. That is 99% of the work that you are going to be doing in IAM. Okay. Log into your AWS account, go to your users, create some user, add their name and everything, add them to a group, maybe not, give them some permissions to work with, and that's it. You have a user created. All right. So far what we did was we created a user, we created a group, added users to your group, we gave them some permissions. Based on those permissions, they were able to log into their AWS account. They were able to see some stuff. They weren't able to see some stuff based on permissions. That's it. I mean, what is access management in just, right? So you are managing access. What is access management? A user should be able to do this not this. That's what you are achieving here, right? So you are giving them permissions to do some stuff. Whatever permissions they don't have, they won't be able to do that. Okay, so let's say you want to create a user who should be able to do each and everything, anything imaginable. Okay, whatever you are able to do as a root account, you want him to be able to do that. So I create a user, super user. Okay, so this is my super user. I'm giving him AWS console access, and he will be able to reset the password. So attach policies. So here is something. Okay, super. No. See, administrator access. So what administrator access gives them is, come on, out of 221 services, he gets access to 219 of those. Okay, so this is the max access that you can give to someone. Now, what are those 2 services that he's not getting access to? I'll show you. Let's give him access and then see in the management console itself. Okay, no key, and super user is created. So if I go to this policy and I see his permissions, see, he's not able to go give IQ permissions. These are the 2 things that he's not able to give. So these are ways to completely destroy your AWS account. So the power to destroy your AWS account lies only with the root user who has access to all 221 of those services, right? He has access to 219 of those, and these 2 permissions are not there. These are 2 permissions that can really destroy your account. So these are actually ways to talk to Amazon. Okay, I don't want this account, just delete it. Okay, that way you lose all your data, all your servers, whatever you have created, it's all lost if you talk with this service and ask Amazon to delete my account. Okay, so your admin can do each and everything, but not destroy your account. Okay, so let's verify that, and let's go to here and try to log in with my super user account. Okay, this is my account. Click on sign in, and I will have this. So it's asking me to change my password. I change my password. My password is changed, and I should have access now. All right, so all the access is there. I won't even see IQ, I think. Accepting the responses. And if I go back here, this won't actually be submitted. See, so it's requesting responses. It won't be submitted ever. It will always be requesting responses. So super user access is equivalent to your root account, but with small access that is not there. So you're not able to talk to Amazon directly. You have to have a root account to do that. So this is how you create users and groups and permissions and so on. So permissions let you control access to AWS resources, and you can have permissions granted to users, groups, and roles. Users are your normal users, user 1, 2, 3. You can have n number of users. You can have groups wherein you can add multiple users into a group, and these permissions are permissive. So when you create a users, by default it has 0 permissions, right? So it asks you to, okay, what permissions you want to give, and they get only those number of permissions. A user would not be able to do anything else except the permissions that you are given him, right? So if he wants newer permissions, he wants to do something else, he has to request you, who has the access to the root account, to be able to grant those permissions. You can attach a policy to specified permissions. So a policy can have multiple permissions, like say EC2 full access policy comes with access to EC2, access to VPC, access to CloudWatch, and so on. And policy consists of action, resource, effect, and condition. So action is, okay, you want to read, write, or delete whatever. What resource? EC2. Effect, yes or no. Condition, when logged in or logged out. That's it. A policy, as I explained, is given to another AWS resource. It can be an EC2, it can be an S3. So when you have your AWS account, do create users and groups. It will really help you to navigate like what all is expected out of you, what all things can you do with users and groups, how they mix and match. And it's completely free. So go crazy with it. Do anything you want in IAM section. You won't be charged a single penny. So really look around and experiment with it. So this is how a policy actually looks like internally to AWS. You can also see it. So what is doing? Version, this is the version, this is the date. Statement, effect is allow. You want to allow what service? EC2 service with action name something and resource. So let's see an actual policy, right? So don't worry about it. Like it looks a bit cryptic, but it's really simple. So let's see an actual policy here. If I go to audit, see the permissions that I've given him. Okay, so show policy. So see, EC2 describe. On EC2, I won't be able to describe on any resource and the effect is allowed, right? I want ELB to describe allowed. And this is really simple. So these are only read-only policies. You should be able to list metrics, describe, and so on. So all these are just read-only things. List, get, describe, right? So if I go to some create policy that has create things in it, so you don't have to write these. You don't have to know the syntax and everything. All these are built in for you. Okay, let's go to EC2. Go to EC2 full access. Okay, look at it. Look at JSON. So EC2 star. Any action on EC2 is allowed. Any action on elastic load balancing is allowed. So this is your EC2 full access policy. So full access have any action allowed, any action allowed, any action allowed. So all these are allowed, right? So based on the access that you want, these policies are automatically generated for you. So this is how AWS access management works. Like we saw, we created one user. We gave them full access to EC2 as well as S3. He was able to access both EC2 and S3. Then we created another user, user 2. We didn't give him access to EC2, but gave him access to S3. So he was not able to reach to EC2, but was able to reach to S3. Similarly, another group was able to reach to S3, but not EC2. So you can have mix and match. So administrator was able to reach everywhere. So depending on the policies that you give him, the layer at IAM stops them or grants them access according to the identity that you have attached with them. All right. So the next step that we are going to do is to safeguard you people so you don't get any surprises in terms of AWS billing. Okay. So AWS comes with a free tier. All right. So when you create something and it's in free tier, you don't get any charge, which charge is $0 for that. But if you exceed that, you will be charged the standard rate that is there for each and every service. So if you go to any service, say you go to EC2, right? So EC2 has some pricing. So I go here, EC2 pricing, right? Just Google it and you will be able to tell, okay, how much is the pricing. So there are two. So let's go to on-demand pricing. Okay. And here it is. Come on, load up. So every region has a different pricing, right? And it's billed per hour basis. So maybe you are in US East, Ohio region, and you spin up a small A1 medium server, you will be charged 0.0255 per hour. Okay. For one CPU and 2 GB of RAM, this is what you are charged. Okay. You spin up. So these are really starting numbers, and it can go really high if you spin up large instances. See, $4 an hour. All right. And there will be something around $5 an hour. There will be something around even more, I think. Okay, $3 for this one. See, $7, $14 an hour. So if you end up spending spinning up those in maybe 10 hours, you will be charged $140, right? So you have to know when you are in AWS console, you have to know what you are doing, right? So that's why I don't want you to, keep following me when I am explaining the things to you, because you miss out on many details that might cost you. though AWS reimburses. So if you are in a dev account, you are in a free tier account, you tell them, okay, it was a mistake, I was learning stuff, that's why I ended up, spinning this. They'll reimburse that for you, but that would only be one time. They won't do that again. So one time was first mistake is forgiven by AWS. But why we have to make that mistake even, right? We can make informed choices and not make any mistakes, right? And if you want to see if you are getting charged or not, go to your AWS console, scroll down here, go to my billing dashboard. You will be able to see if you are getting charged or not, right? If you go to your billing dashboard, it will show you the currency, right? So it will show you how many dollars are you charged if you have made any request. So see, top free tier S3, 0.01% I'm charged, right? So I'm not charged anything because I'm less than 1%, less than something. So even if I make 2000 requests, I won't be charged. But yeah, 2001th request, I will be charged. Okay. So I'm not charged anything. And if you go to Cost Explorer, it will tell you how you are getting, okay, you can set your budgets. I want this budget. I don't want to exceed this budget. You will get an alert and everything. So what I want to do is whenever you are exceeding your limit, I want an email to be sent to me, right? So whenever I exceed my limit, so maybe I get charged $1. As soon as I get charged $1, I should get an email. So if I get an email, I will be warned and I can go on account and delete the stuff that is charging me. So how you go about doing that? Go to services. Okay. Let's first see here. So see this billing preferences, click here. First step is checking this, receive free usage tier alerts. Turn on this feature to receive emails when AWS usage is approaching or exceeded the free usage tier. So as soon as you create something and it starts reaching the end of your trial, you will get an email. And as soon as you exceed that, you will keep getting email every hour. Okay. You also get billing alerts. Okay. Turn on receive billing alerts. So how can you manage those alerts? Just click on manage billing alerts. When you click on manage billing alerts, you will be taken to this page. You see this billing, right? Click on billing and you don't have any alarm right now. So alarm will send you an email. Click on create alarm. Okay. So you want your estimated charges in US dollar over a period of 6 hours. What will be your threshold? If it exceeds $1. So as soon as the charge exceeds $1 over a period of 6 hours, you can even do 24 hours. You can even do 10 seconds, right? So you can do a minute. In a minute, if it crosses $1, but that is very short. You won't cross $1 in a minute unless and until you're spending something really big. So let's make it 6 hours, or you can even make it a day. So let's make it a day. So if in a day you exceed $1, you will be given an email. So let's for now keep it 6 hours. Use a static value greater than 1 hour. Click on next. Okay. So when you want your email to be sent, when you are in alarm means that you have exceeded the $1, right? So create a new topic. Enter the topic name, inform me of billing. Okay. You just put in a name, inform me of billing, and which email address. So invalid. Okay. I have to put underscore here. It is not giving me spaces. Inform me of billing. So what is the email that you want this to be sent, right? So you want it to be sent to some email, your own email. So you get an email as soon as you cross $1. So I entered my email and I clicked on create topic. As soon as you create topic, your topic is created. Okay. Click on next. You enter an alarm name, billing alert free tier. Okay, and you click on next. Preview and create. Okay, greater than $1. All right, and I have created it. See, my alert's been created. So right now it's showing insufficient data because I have set it to 6 hours. So it needs at least 6 hours of data to start working. Okay, because if I had set in 1 hour, then within 1 hour it has data to start working on it, right? So now after 6 hours, this will start working. So in 6 hours, if you cross $1, it will give you an error. And if you don't, it will be, so this is pending confirmation. You click on here. So it will show you it's pending confirmation, right? So SNS topic is pending confirmation. Don't worry about it. Just go to services, click on SNS, click here. You have your topic that you just created. This was inform me of billing. And you see it's pending confirmation. So what happens, the email that you entered here, right? An email will be sent to that on that email address, and there you will have to confirm, okay, yes, I want to subscribe to all the updates that are coming. So I go to inbox, you will see subscription confirmation. So you just have to click on confirm subscription. As soon as you click on confirm subscription, your subscription will be confirmed. And here the status will change to confirmed. So this is what we did today. So we created users, we created groups, gave them permissions, and played around with those users, how they are interacting with each other, how we can control access, how we can give all of the access, how we can give only read-only access, how we can take away access, how we can add tags. So this is all we did. So today we will be stepping into storage world of AWS, right? Storage world of AWS has a few products. If I go to the console here real quick. So these are all the storage products that are there. And the most important storage product of these is my S3, right? So S3 is simple storage service. Simple storage service in the sense, so the name itself says it's simple because it's very easy to use, it's very easy to set up, it's very easy to start. So you can put your content there very easily, and you can start using it right away after a few clicks of button, right? And it's really easy to configure as well. You get this nice UI. Just have to follow the steps that I will be showing you shortly. And if ever you want to read more about S3, here at the top you have documentation section, right? So if you click on documentation, right? So documentation enables us to read through all the AWS resources that are there on Amazon.com related to S3. Maybe you are just getting started. Maybe you need a developer guide. Maybe you need an API reference. Maybe you need a console user guide. So all the material or all the books that are there out for S3 are available for free on AWS itself. When you go to AWS console, the documentation is here right under support, right? So you have to click here, you'll be taken here. And you don't need to go here, but yeah, if you want to just deep dive into S3, you certainly can. Yeah. So let me go back to my PPT. All right. So these would be the topics for today. I'll be quickly going through S3. Then I'll create some S3 buckets. I will put content in. I will show you how you can upload your data, how you can download your data, how you can version control your data. Say you change your data over time, how to keep all the copies that you are changing. And cross-region replication would be having my data in more than one region. As you know, AWS has 24 regions. So you can, in theory, keep your data on all 24 of them, right? So that way, even if one region is down, right? One region is 3 data centers at minimum. Even if one region is down, you have 23 other regions that have your data, and your users will never experience that they are not able to access their data, or you will never experience that you are not able to upload any data or download any data. Yeah. And then we will look at lifecycle management, how the data lives in S3, how it goes from there, how you can move it to Glacier. So don't worry about it. As we go along the class, you'll be able to learn it. You'll be able to understand it. Yeah. So this is storage and so on the console. So when you go on storage tab, this is what you see. These are the storage products that AWS offers. Yeah. So first product is AWS Simple Storage Service. So Simple Storage Service is the object-based storage. What do you mean by object-based storage? Object-based storage means everything that you store, be it a PDF file, be it a text file, be it your photo, be it your video, anything that you store has an identity of its own. So when you store something on your hard drive, on your laptop, or maybe on your phone, when you are storing something, everything is kind of grouped together, right? So even though you see individual folders and files, at the end of the day, internally for the phone or for your computer, it's all same. They just have to go serial wise and look at those storage objects one by one. But when you are using simple storage service, all the identities, all the objects that you have stored, all the files that you have stored have their own identity, right? And S3 is almost 99% similar to your iCloud Drive or maybe Google Drive, right? So Google Drive or iCloud Drive are exactly similar to S3. So S3 is Amazon's way of doing Google Drive or Apple Drive, whatever it is, iCloud Drive. Yeah. So it's 99.9999999% durable. That means throughout the year, the chances of your data not being able to access that data is 100 minus 11 nines. Yeah. So that means out of an year, the chances of you not being able to access your data is less than 1 in 10 million. Yeah. So you also have to think about this. So AWS stores huge amount of data. So lots and lots of, like, whole of Netflix is streamed from AWS itself. Yeah. So imagine how many movies, how many TV shows, how many documentaries and everything Netflix has. Spotify is streamed off AWS, millions of songs. So Spotify not being able to serve a song that they have stored in S3 is less than 1 in 10 million. So this is the reason why Spotify or Netflix for that matter are so reliable. They're never down. Even if they're down, they're up in a minute because they are on AWS, which is giving them such great amount of durability. So their data is always available and they're able to serve their customers always, right? Another thing is the data is secured. So whenever your data is in S3, right, it's secured, it's encrypted, nobody can read it except the owner of that data. Yeah. So if you're not the owner of that account, you won't be able to get to the data unless and until you specify, okay, I want this data to be public. Yeah. So public is like saying, okay, this is my website, anybody can visit it. Yeah. But if you don't make your bucket public, if you don't make whatever file you've stored in there public, nobody except you would be able to access that file. Yeah. So maybe you want your S3 to be accessible to certain number of users. You can do that. Create the user in IAM, right? Give them S3 access and they'll be able to access that. Yeah. And maybe certain users you don't want accessing your S3. Don't worry about it. Just go to IAM, remove S3 access from them, and they won't be able to access S3. So with the help of IAM, you can control, okay, this person can view my data, this person cannot view my data, this person can read my data, this person can also upload to S3, also change the data in S3. Yeah. So that way I can have very granular control over S3, over the data stored there, and I can be serving my customers with 100% availability. Yeah. So let me go to console. You go to services, you go to S3, or you can type S3 here and you will be taken to S3. So there are two, S3 and S3 Glacier. Today we are studying S3 only. Yeah. So once we come to S3, this is how it looks, right? So the first step in using S3 is to create a bucket, right? So bucket is like a folder. All your files that you are going to be uploading will exist in this bucket, right? So just click on create bucket. Okay. Now you have to fill out this small form like step one. Okay. what is the name of this bucket? So this bucket's name should be unique in whole world, right? So if you, because this bucket will be available over internet, even if you make it public or not, it's still going to be available on the internet. But yes, if it's not public, nobody be able to see your data or upload your data, but still it has to be available over the internet for it to be highly available, for it to have that 11 nines of consistency, right? So let me put it like my first bucket, my first AWS class bucket, my AWS class first bucket. Okay. So now I get to choose where I want this bucket to be. Okay. I have chosen US East Northern Virginia. Don't worry about it. Click next. So if that name is not unique, it will give you an error. Okay, I'm not able to create this. Okay. Now, the second option that you see here is versioning. Keep all versions of an object in the same bucket. That means whenever you change an object, so maybe you have 5 files, 5 small text files there, right? And somebody else comes along and they delete one of those. Okay, and somebody else changes the content of the text file, same file but with different content, right? Now when you come tomorrow, you are looking for those files and they are simply not there because somebody has changed them or somebody has deleted them. If you have enabled versioning enabled, AWS will keep the versions of your file. So as you are changing files, it will keep recording those changes and you can revert to a previous version. Even if somebody has deleted, you can just go back and restore that file. Yeah. So this is the how the versioning works. If you want to learn more about versioning, if you want to read about it, there is a small article. Just click on it and it will take you to this page where you will have everything explained about versioning. See, it's a one-page article. So maybe when you're traveling to work, maybe you have a couple of minutes, just go there, click on it, and you'll be able to see it. Yes. So versioning enables us to keep the records of a file if it ever changes. Yeah. So server access logging. So this is my second option there. So what is server access logging? Log access for request to your bucket. So say somebody comes along and they downloaded something from S3, they uploaded something to S3, they just viewed some files. Do you want to keep those logs or not? So like yesterday you asked me, okay, if I do something with my AWS account, would they be able to know, like if I have deleted someone, if I have created someone? So you can always enable logging. For sensitive services like IAM, it's always enabled, right? But for some services that are not that sensitive, you can always enable it and you just have to click log access request. So now when you are logging, you have to have another bucket, another target bucket, right? Where you will be storing those logs. Okay. So you want to store those logs somewhere else, you have to just put the bucket. So let me create. So for now I'm skipping this, but we will enable it because I'll be needing another log bucket for that. Now tag is something similar that we did with IAM, wherein we created department and then we created its value. I'm not going to create it for this because it's just for decorative purposes. Now see this object level logging. So this is bucket level logging. If somebody is coming into your bucket or not. This one is for objects. So do you want to log at object level or do you want to log at bucket level? Bucket level is, okay, somebody this did something to this folder, but the object level will be somebody did something to this file in this folder. You're getting, for server access, you are only monitoring that bucket, that folder in which all your files are. But for object level, you are monitoring files as well. Okay. You can enable it. You have to create a cloud trail. For now, just skip it. Just keep it simple. Now, default encryption. So default encryption is something when you upload a file to AWS. Yeah. When you upload a file to AWS, when it's just staying there, you're not downloading it. When you're downloading it, definitely you're downloading it over a secure port and everything. Nobody else can see it. Nobody can intercept your download. But when it's just staying there on AWS server, right? Do you want it to be encrypted or not? Do you want it to be password protected? If you click on it, there will be two options. One would be AES 256, another would be AWS KMS, right? So if you go with AES 256, it will just encrypt your file, and when you are downloading it, it will send that file after decrypting to you. When you are using AWS KMS, that is key managed service, you are providing AWS a key. So you can generate a key in AWS KMS. It's another product. We will work with that product in future, but for now, just keep it simple and do use AES 256. Yes, there is an option to not trust to AWS with their encryption. You can supply your own encryption mechanism with AWS KMS, right? Now, permanently allow objects in the bucket to be locked. This will just allow you to lock your objects. Lock your objects means once you have written the object, once you have created that file, you cannot edit it, right? So see this, write once and read many. It's called worm model. So once you have written an object, once you have uploaded a file, it will just stay there. You cannot change it. If you want to change it, you have to delete it and then upload it again. So this is the locking mechanism that AWS offers. I'm not going to use that. And you can also request CloudWatch metrics. Okay, how much data is going in, how much data is going out, and so on. So for now, I'm just keeping it simple. I'm just encrypting my data. I'm just keeping all versions of my object. Next, I click on next. Now here you can allow or block the public access to your bucket. So see, block public access. So public access is granted. Say you want something to be uploaded to S3, which you later want to be accessible to all the users. Maybe you are Netflix and you have uploaded a movie to S3 and you want that to be accessible to all the users. That's not how it works for Netflix, but I'm just giving an example. So what they'll do, they'll create a high definition file of a movie, just upload it to S3, and then each and every user on their application, they will see a S3 URL in the backend, and when they click on that URL, they'll be able to download that file, yeah, and they'll be able to see the movie. But right now, I'm not going to become Netflix or Spotify, so I'm going to block all public access. So this is blocked by default unless and until you have a very good reason to unblock this, right? So it will ask you again, okay, do you really want to unblock it? The reason is sometimes just people create public buckets and they put sensitive information in there. Because it's open to world, it can really leak, right? Somebody can download that information. So a lot of big companies, lot of really big companies have made their mistake and they have paid the price, right? So if you go to Google, right, AWS S3 public hack, right? So you will see how I hacked Amazon S3 bucket misconfiguration. So there will be tons of resources, right? So FedEx like exposed private info of thousands of people because they left their AWS S3 bucket public in which they were storing their customers' data. So you can really make mistakes there because you are on internet and you are able to access it. Somebody else might also be. It all comes down to the permissions that you have set, the safeguards that you have set around it. If your safeguards are not good, they'll be able to access your info. Yeah. So the best safeguard that you can provide right now is block all public access. Then you click on next. Okay. So here it will tell me to review it. My bucket's name is my AWS class first bucket. My region for now is US East, Northern Virginia. I have versioning enabled. Rest all things are disabled except the encryption, and my public access is blocked and system permissions are disabled. When I create this bucket, right? Okay. So this is my first folder or bucket that I have created inside AWS, right? So I'm getting my date, I'm getting where it is, it's in one region, I'm getting how many buckets I have my bucket itself. And if I click on that bucket, now I see the upload button. I also see the create folder button. So let me upload something here. So see this, To upload a file larger than 160 GB, use AWS CLI or SDK or REST3 API. So what is the reason behind that? Why it's saying 160 GB? If your file is very big, you should use a bigger, some kind of programmatic method. Okay. So if you want to upload a file larger than 160 GB, so what happens is if you are uploading it from your laptop, right? So your laptop might not be able to support such a big file in an upload manner. Another thing is your internet connection can stop. So if you are using AWS CLI or SDK, they have pause and resume functionality. They can break your file in smaller components and upload it like that. So you have all those options. But when you are uploading via laptop, you don't have all those. Maybe I'll upload this file, this same file that I created yesterday. So here it is. I click on upload. I can set individual permissions for this as well. So let's set that. So I put that file in. So first is manage users. Yeah. So who all access have this? So this is my account name. I have read as well as read write objects. Okay. I can give access to other AWS accounts as well, but right now I'm not going to do that. Manage public permissions. I have blocked public access for the repo itself. Okay. So here is the storage class that AWS gives me. Okay. So first is standard, frequently accessed data. So it will be available in at least 3 availability zones within a same region. So a region has at minimum 3 AZs, 3 availability zones, and this data will be replicated across all 3 of them, right? It will be one URL. I'll be giving only one URL, but yes, it will be available across multiple of those. Okay. Then I have my intelligent tiering. This is for long-lived data with changing or unknown access patterns. So this is how it works. There is some data in an organization that is accessed on daily basis, right? Maybe there is your attendance, maybe there is your files that you work with on daily basis. Maybe there are some accounts, files, or something like that. Then comes some files that are used maybe once or twice a month. They can be used for all 7 days, but then they are not being used for a month and then they start using it again. It can be some sort of training material. So maybe you have hiring every month, right? So whenever a new hire comes in, you have to access those training materials for them. Yeah. So that way, maybe you don't hire anyone over the period of 30 days. Maybe you can hire a bunch of people over that 30 days. So you can have intelligent tiering for that kind of data, right? So then you have standard infrequent access, long range, but infrequently accessed data. Maybe you have something like log files, a recent log files, maybe a month old log files. You want to go out there and see, okay, what happened, right? What are the logs? How can I view those? Then you have one zone IA. This will be replicated into only one availability zone, right? So you're putting your data into only one data center. So if that data center is out, you won't be able to access your data. And definitely it's cheaper. So this is most expensive, less expensive, less expensive, less expensive, very less expensive, and this is almost very cheap, and this is also very cheap. So one zone is one data center. Then you get Glacier. So archive data with a retrieval time ranging from minutes to hours. So all this you can just click and you will get your data instantly on a click of a button. Yeah. But with Glacier, right? If you want some data, you have to request that. Okay, I want this data. You click the button, AWS will go look for that data and come back. Okay, now I have your data, because they're storing that data on not hard drives, but on tape. So they have tape drives, massive tape drives inside. It takes time to spin that tape, find your data, and make it available to you over a hard drive. But yeah, it has more than that. Then you have Glacier Deep archive data that rarely, if ever, needs to be accessed with the retrieval time in hours. This one has from minutes to hours, maybe from 5 minutes to maybe 2 hours. This can range from more than 5 or 6 hours. Okay, so this one is really slow in retrieving. Once you have made the request, though, after the data is available, you can download it at normal speeds. But yes, for requesting that data, you have to put your request and everything, and it will take a long time. And then you have reduced redundancy. Okay, so this is not recommended. Why it's not recommended? Because standard storage class is way more effective. This one is way more effective. rather than using reduce redundancy. So it's almost same, but if ever a customer comes in who is paying AWS for standard access and AWS don't have space for you, they can knock out your data from one of the data centers. Yeah. So with standard, you are guaranteeing it will be 3, but here it can fluctuate, it can change. And the pricing is almost similar for standard and a reduced redundancy. It's not much of a difference, maybe less than a tenth of a cent for 1 GB. So it doesn't make any sense to, go for reduced redundancy. So for now, I'll keep it standard. Okay. So whatever you want, like whatever data you have small hints here, what kind of tier you want to select. Based on that, you can select it. Okay. So do you want encryption? Yes, I want encryption. Let's do with Amazon S3 master key. Do you want any header or anything? I'm not going to do that for now. It's just a way to log it. So review. One file, one permission, standard access, encryption, yes, no metadata, no tag, and click on upload. As soon as you click on upload, you will see one operation in progress. It started, it's completed, and now you have your file on AWS. Okay. Now, if I click on this file, okay, I click on here, I'll be able to download. Yeah. So if I click on download, I'll get that file. It's downloading. Now, let me take this link, right? So this is the link to this file, and download it from maybe an incognito window. This is a new window. I am not logged in here. Let me do it. See, access denied. Why? Because I'm coming in not as my authenticated user, but I'm coming in as public. So it's giving me access denied. If ever I make this bucket public, I will be able to download this file. Let's do that right now. Okay. So my first bucket, go to permissions. This is it. Okay, block all public access, done, save it. I have to type confirm. Now my bucket is public. Let me look at my object, look at object's permissions. Okay, I have to change its permission as well. Okay. Okay, so public access, everyone. So what access I want to give? Just read object. Okay, I'm going to click save, and if I go there again, I should have access. See, now I'm able to see that PDF. Now I'm not getting access denied, right? So what I did, I first went to the bucket, right? So this is my S3. I clicked on the bucket. Okay, I'm inside the bucket. Then I clicked on its permissions. This is bucket permissions. So it was block all public access was on, right? So I clicked on edit. So it was like this. I unchecked it and then I saved it. It asked me to confirm, okay, do you want to make this bucket public? I said, yes, let's do it. Let's do it. So my bucket was public. I again went here. Then I selected this object. As soon as I selected it, this small window popped up and I clicked on permissions. As soon as I clicked on permissions, it asked me, do you want to give public permissions or not? I clicked on everyone. Okay, I want to give public permission to everyone. So then it asked me, okay, what kind of permission? Just that read permission? Do you want to read object permission, write object permissions? What do you want? I just read the object. I don't want to be giving, people access to permissions and everything. I just want them to be able to download this file. Clicked on save. As soon as I clicked on save, I was able to download. Now, what if I have to remove the public access? Same process. Click on everyone, right? Remove this, click save. Public access is removed. You will no longer be able to download that. I also have to remove public access from this bucket itself. So I click on bucket permissions. I click on edit. I block all public access and I click on save. So it asks me to confirm. I click on confirm and my public access is removed. Now when I go into an incognito window and type my AWS API, I won't be able to access it. Okay, so it's a bit simpler than IAM, right? Because in IAM there are a lot of permissions. There are around 240 permissions, lots and lots of products. Okay, so another thing. So whatever I've done till now, it's covered in free tier. Okay, but if you go for cross-region replication, you won't be covered in free tier. So you will be exceeding your free tier limit. Okay, so let's go to S3, click here. So you go to management, right? In management, you have to go on replication. On replication, you have to click on add rule. So what you want to replicate? Entire bucket. Okay, click on next. Where do you want it to be replicated? So you have to create a bucket in another region as well. Okay, so let's create a new bucket. What would be the bucket's name? So let's take this name itself. So it's already owned by you, so it won't let me. So let me ask it one. And see, that one was US East, Northern Virginia. Let's say I want to do it in California as well. Yeah, now it's in California. So do you want to change the storage class? I don't want to do that. Time control, how much faster do you want? Within 15 minutes. Okay. Change object ownership to the destination bucket owner. No, I don't want to do that. Click on next. When you want to copy data from one bucket to another, you want to have S3 access enabled in IAM for that bucket. Okay, so let's create a new role. Name of the role would be S3 cross region access. Okay, click next. So you created S3 cross region access. So why is this IAM role required, if you ask? So this IAM role is required because now we are talking about two buckets, right? So you will be uploading your data into my AWS class first bucket, and it will be replicated to another bucket that is in another region with a different name, right? And you can have multiple buckets with different names and they will all point to same data. Now what happens? This AWS bucket, that bucket one, is not same as the other bucket. Maybe they have same data, but they won't carry same permissions, as each and everything in AWS works on the concept of minimum access. Even AWS resources cannot access each other without your permission, without you granting them IAM permissions. So you have to give them permission. You have to give them a permission to read data from each other, upload data into each other, so that they can fetch the data from there into the replication, right? When you click on save, you will create a bucket. Okay. Okay, let's see. See, now my cross-region access is enabled and my replication is enabled. So my source bucket is my first bucket and the destination bucket is first bucket one. This one is in Northern Virginia, this one is Northern California. So you will be charged twice the amount because you are keeping your data in two regions. So you will be charged for standard access into two. So what is the pricing for AWS, if you ask, right? So just go on Google, click on pricing AWS S3. Okay, so pricing. Click on first link. This is the pricing. So for S3 standard, for in Ohio, or maybe we can look at Northern Virginia, for first TB in a month. Okay, so you 50,000 GB of data. First 50,000 GB of data will be billed on 0.023 per GB. So if you upload, say, 10 gigs of data, you will be charged 20 cents, 23 cents in a month for 10 GB of data. If you upload 100 GB of data, you would be charged $2.30, right? And this pricing will continue so on till 50,000 GB. For next, from 51,000 GB to 450,000 GB, you will be charged 0.022. Okay, and then over 5000 TB. So people actually use over 5000 TB. They use 500,000 GBs. It's no big deal. They do. Imagine something like Netflix or Spotify. They do use that. Then you will be charged 0.021 per GB. Okay. So this is the pricing for S3 standard. This is for S3 intelligent. Not much of a difference if you see for first 50 TB. Yeah. Infrequent access, yeah, very different. Like it's almost half the price. One zone, even cheaper. Glacier, more cheap. And Glacier Deep Archive, see how cheap it is. But yeah, you sacrifice your usability when you are doing that. Okay. So this is the pricing. So when you are doing cross-region replication, say you have 100 GB. So for 100 GB, you are charged $2.30. So with cross-region replication into two regions, you will be charged $4.60. Okay. Let me pull up an exam question. Okay. So this is a blog that one of my friends had set up quite a while ago. So he was one of the first guys who really went out there and collected all the resources about AWS and put it up in small web pages. I'll share this link with you. So these are the questions, like what does AWS S3 stand for? Okay, this is the actual question from AWS Solution Architect exam. You have to know simple storage service. Okay, what are characteristics of AWS S3? Objects are directly accessible via URLs, host as a relational database, very limited size. What else? No, these are two options, right? You are building an automated transcription. So this is more of a good question that comes in. So you will get these questions but these will be like 4 or 5 questions. You have to answer a total of 45 questions. Out of that, you must answer, I think, 30 or something. So yeah, this is another question. So this is a good question. So you're building an automated transcription service in S3, EC2 worker instance, processes an uploaded audio file, generates a text file, and you must store both of these files in the same durable storage until the text is retrieved, right? So you do not know the storage capacity requirements are, which storage option is cost effective and scalable. Now, what this problem statement say? You're doing something on Amazon EC2, right? Don't pay attention to like transcription service and instant processes. Just focus on AWS services, what it's trying to say. You're using Amazon EC2 to do some work on some files. Okay, these are files, and you want to store these files, and you should be able to retrieve it. Okay, look for the verbs there. Okay, what you want to do, and the capacity requirement should be, there can be unlimited number of files, and what is cost effective and scalable. Okay, so if you are already on EC2 and you want to store something, right? So for storage, you have to go for some kind of storage mechanism. Now it has to be cost efficient, scalable, and fast, because you want for it to be available. Okay, S3. Another thing, EBS volume snapshots, when you will study about it, you cannot really download from them. Okay, so that's out. Multiple instance stores, that's out, because you are already working on EC2 instance. Why would you look for another instance when you are? So that's out. And then you are left with these two. Okay, so Glacier, I told, is very slow. It takes hours and hours to get the data. So you cannot have a user service that needs frequent access with Glacier. So the only option is a single Amazon S3 bucket. Okay, yeah, so this is how it works. So what you have to do is, like, when you are studying S3, once you are very comfortable around moving around, then what you can do, okay, you can solve a few of these questions. So you have lots of like 15-20 questions are there, 13 are here, some will be in the comments. Just read through these sessions and you will get to know, okay, these are the parts AWS is asking questions about, and these are the ones that I have to pay attention to. Okay, all right, so that's how you upload something into S3. You download it from there. So what if you want to delete this, right? So you go to actions, you go to delete. As soon as you click on delete, and your bucket is now empty, right? So now, as you had enabled versions, remember we enabled versioning a while back. Even if I have deleted that, right? So it has kept a log. Even if I deleted that, my file is still here, right? So if that was an accidental delete, I can always retrieve it back, right? So I can always retrieve it back. It will always be here if it was an accidental delete. So you don't lose any data because you made a mistake. Now, if you want to remove these versions as well, then you have to click on delete. Okay, so you will be removing the versions as well. So it's great, like it shows you all the versions, but yeah, you should be careful. So if you keep on changing a file, it will keep storing all the versions, right? So after a while, you will be taking massive amounts of space for same files. So you have to go out there and flush the versions out that you don't need, right? But yes, it's a great safeguard to have. If your data is important, you always have versioning and you can always move back to that data. Okay. So this is the versioning. What's the versioning all about? Now, there is a very good use case, where you can host a static website on S3. Okay. So what you can do is when you want to host a website, traditionally you need a server. Okay. But S3 provides a functionality where you can host a website on S3 without using a server. Okay, so what you have to do is just select S3, select your bucket, click on properties and click on static website hosting option. So let's do that right now. Click on properties and this is, so use bucket to host a website. Click on it. So what would be the index document? I click on index.html. Okay, so do you want an error document? Error.html. So HTML is actually your web page. Okay, so redirection rule, I don't want any redirection rule. I click on save. Let's see my permissions. Block all public access, but I want my website to be publicly accessible. So I remove. I click on confirm. Okay, and it's confirmed. So now I have this. So static website hosting is on. So if I go here right now, it will be empty because it's nothing there. So let me create a index.html file and upload it here. Okay, so text edit and hello, hi. So this is a small file that I'm going to save. So it's index.html. Okay. Okay. Right. So I saved it. Let's see where my file is. It should be in documents. Here is my index.html. I will have to upload that. Add files, index, upload. Next. So grant public access because I want this to be accessible to everyone because it's a website. I click on upload and we have upload. Now click here. See, this is my website. So I'm not just downloading this file because I'll be downloading. I will be getting it like this, right? But as I have hosted it as a website, so I have my own website. So you can have your own website as well if you want. Okay, just create a bucket, put a file in there, index.html. Whatever you want to write in your website, you can put there and you will have that. Okay, cool. So this is another use case for Amazon S3, wherein you can host your websites. Okay, so what all steps you have to take to host a website. So go to S3, click on my first bucket, whatever your bucket is, click on properties, static website hosting. You have to click there, you have to click this, you have to provide them the index document. Okay, you have to provide them the error document. I haven't provided, but you can, and then click on save. Once you've done, So your static website hosting is ready for that. Now you want to upload this index.html. Another thing is the permission should be public because you want this website to be accessible over to all the public. And then you upload a index.html file. In this index.html file, you can write whatever you want and just upload it here, and you will have a working website in no minute. Looks good. Really easy. So maybe you can all come up with your own websites on S3, and anybody can, you can share whatever you want. Maybe you can start a blog on S3 itself. Okay, so all your blogs can stay here. Okay, so we looked at version control, right? How the version control works even when we deleted the file. So what is actually Amazon CloudFront, right? So Amazon CloudFront is a cloud content delivery network. It can also be called a cloud distribution network. It can also be called cloud delivery network, but the right answer is content delivery. Why we call it content delivery network? So what is content? Content can be anything that your user wants, right? It can be a PDF, it can be a video file, it can be a audio file, something like that, right? And they would be wanting it to use, like suppose if you are a Netflix class customer, you need their documentaries, their movies, their shows, you should be able to download those, right? So that's the content for Netflix. Maybe you are a company who has an online bookstore, so then the PDF of that book is content for your users and you want that to be distributed. Now when I am putting my content in S3, right? So when I am putting my content in S3, right? So it will be distributed. I have an option to just put it in any one of the regions, right? I will put in either US East region, whatever the region I am putting in, I'll be putting in one of these regions. So, right, because I am not doing replication by default, so I'll be putting either in US East, US East 2, US West 2, one of these regions, right? But what if I want more granular control of where my data is? I want it to be even more distributed than regions. So right now there are 24 regions to leverage AWS huge network of point of presence. So let's look at AWS CDN POP. Okay, so this will tell me where all their pops are, right? So if you look at this blue dot is pop, the purple one is the multiple edge locations, and this yellow one is the regional cache. Okay, so see how many low, like, regions are quite low in number if you see that, but number of pops are way more than the number of regions we have, because pop is easy to set up. So pop for AWS or pop for you is like a smaller version of a region, right? So currently AWS has 216 pops as opposed to 24 regions. Okay, so if you look at AWS regions, right? So if you look at AWS regions, the regions are only these, right? These are only these are your regions. Okay, so these are 24, but if you want more points of presence, you can have 216 of them, right? So when you have 216 of them, even if the region is maybe more than 500 miles away from you, the pop location will be less than 50 miles from you. So that means your data will be traveling less amount. When your data is traveling less amount, you will be having better latency, better speed. Your user will be able to access your data faster, right? So that gives your user a better user experience, right? So that is the reason why we go for CDN, or for that matter, AWS CloudFront. Okay, so there are a lot of CDNs in market actually. So you have your Akamai, you have your Fastly, you have your Google CDN, you have your GitHub CDN, but in AWS world, the CDN is called CloudFront. Okay, so what it provides? It provides low latency and high data transfer speeds. Why? Because your content is now much closer to the user, as opposed of it to be coming from a region, it is now coming from a local location. Now how they do that, it's really ingenious of them how they do that. So your actual resource, Actual resource would be either the content in your S3 bucket or EC2. Maybe your server has some dynamic content, right? So your S3 and EC2 will stay in the region wherever you have created them, but CDN will create a small copy nearer to the user. So what CDN will do, it will come to AWS, right? AWS S3, for example, it will look at the content. Okay, has it changed in last 5 minutes? No, it hasn't changed in last 5 minutes. So they will keep using that content. If ever you decide to change your content, right? So when you change your content, the CDN will come to know, okay, you have changed the content, and it will refresh the copy it has. So what it does, it takes it from the region and copies it all over the world, right? So your user is essentially accessing the copy instead of actually accessing the real thing. Okay, so that's how they do it. Okay, yeah. So this is how it works. Whenever a user wants to access your content, he's essentially accessing a copy of it rather than accessing the real thing, right? So origin server can be registered with AWS CrownFront through API call /console. You can do it via CLI, you can do it via console, and this will return a cloudfront.net domain. So right now, if you see, if you go to S3, if you click on this object, so your object has a URL or something type, what it is, s3.amazonaws.com. But when I will put this in CloudFront, it will turn into cloudfront.net. We'll see that how it happens, right? So let me go back to PPT. So we'll see how that happens. So what it will do, it will just create a CloudFront.net URL to it. And that CloudFront.net URL will be serving content from one of POPs rather than fetching it from the original S3 bucket. Okay, so here are how it works. So here's your original content on S3, right? Here is your original content on S3. You took the content and moved it to CloudFront, right? So now it's at around 216 locations all over the world. It was at one location, now it's distributed all over the world. Now when your user is accessing it, he will be accessing the CloudFront. Which CloudFront? Out of 216, right? The one that is nearer to him, right? So that way this user gets a lower latency, right? And there is not much load on this original S3 bucket, and the speeds are way higher. Okay. CloudFront CDN content is organized into distribution where content and delivery properties are configured. Okay. So how you go about doing it? Log into AWS CloudFront console, create distribution, specify the distribution properties, and you are good to go. First thing is content origin. Content origin is where your original content is. It can be an S3 bucket, it can be your EC2 server, it can be a media package channel, anything that you expect your user to use, right? Directly. You won't be putting your database on CloudFront because database is for your use, not your user's use, right? Database is for application that you are running. You don't put your application data out there in public. You only serve what a user needs, and that will be either a content, a PDF file, maybe a website page, whatever it is, you will be serving, right? Then you want to specify the access. So the access is like, do you want to make it public? Do you want it to be available only to AWS users? How you want to do it? Do you want to give just read access? Do you want to give write access as well? Everything. You can even configure security. So do you want it to be delivered securely? Means the user must use HTTPS to access your content. Okay, so there are two ways to access content, HTTP and HTTPS. So do you want to use HTTPS or not, right? You can have cookie or query string forwarding. So what you can have, whenever you access a website, a cookie is generated. A cookie is something like identifier. So whenever you are visiting a website, right? So whenever you are visiting a website, you will get a cookie. Okay, so that cookie identifies, okay, which user is this. Okay, so if you want to see how a cookie looks, let me show you one right now. You click on here on your Chrome, you see cookies 20 in use. So I have cookies from Google, I have cookie from Genbask, and if I look at Genbask cookie, so this is one of the cookie value. So this cookie value is helping Genbask to identify who I am. Okay, so this is their way of identifying which user is. So Google sends a lot of cookies. So in case of Genbask, it was one cookie. Look how many Google has sent. So every website that you go to stores some cookie on your computer to identify which user it is. Okay, so these are the cookies that they store. Okay, so similar way you can have AWS CloudFront store cookies on your end. So whenever you try to get that content, you will be having some cookies associated with you. Okay, we'll create the distribution. Okay, so let me go to AWS console and just go to services and go to CloudFront. I click on create distribution. Okay, so what kind of distribution you want to create? You want either an S3 bucket or a web server, okay, or a RTMP. RTMP is for media files, okay. So this is for Adobe Flash Media Player. This is something that AWS will be soon closing because Adobe Flash Media Server is getting axed. Okay, they are no longer going to be web browser who will be supporting Adobe Media Flash Player. So this one is going. So don't worry about this one. You will never get a question or a client requesting you to build a RTMP distribution. Just concentrate on this web one. Okay, so get started. Okay, so what would be your domain? Okay, so this is my domain from where I have to pull my data. So this is my S3 bucket from where I'll be pulling that data. Okay, what is my origin path? Enter the directory name here with the is slash. So this appends to the directory name when you're forwarding your request. Okay, so my origin path is slash. Why is my origin path slash? Because in S3, I have put my data right in the bucket. See, the bucket has slash after it. The data is right there. There is no folder after. If I say create a folder, folder say, right? And if I go to that folder, then my path becomes slash folder, isn't it? But as my data, this PDF file is right there in the bucket, it's going to be slash. Okay, so my origin path is slash. And if your origin path is slash, you should not be like specifying it. It will just take it. Okay, so by default it's slash one. So do you want to restrict bucket access? Okay, and you can have identity attached to it. No, I don't want to restrict access. I want this to be available to everyone. You can create your custom headers. Okay, let's say CDN header is there and I put cloud front. I'll show you what this does when I try to access this. Okay, so viewer protocol, HTTP and HTTPS, redirect HTTP to HTTPS or HTTPS only. So when you click HTTPS only, if user tries to do HTTP, he won't get access. So let's for now do redirect and then get to HTTPS only to see what happens, right? And any field level encryption, I don't want that. Okay, cache based on selector header request, I don't want that. And everything that you want, you can just leave it there. Okay, you don't have to worry about it, but I'll explain everything to you. So first thing, okay, allowed HTTP method. So you don't have to understand HTTP method, but you should know what these do. So HTTP methods are ways to interact with the website. Whenever you are visiting website, you are using one of these methods. So get is like downloading website. Head is like seeing what is in there. Options is like what all methods this website supports. Okay, so maybe a website supports get only, maybe a website support head only, right? So this is not related to CDN, this is just related to HTTP, but yeah, you should know. Okay, and this won't be asked in any exam or anything. It's just there. And get head and options is there. Then you have put is like uploading something, right? Post is like uploading some data, 1 2 3, like a form data or something. Patch is like changing something, and delete is like delete. So you should know about this, like for just journal IT knowledge, but yeah, they won't be asked anywhere, right? So this won't be in your exam. Nobody is going to tell you, and nobody is going to ask for this. And whenever you are creating a solution on CDN, the IT guy, the company for whom you are just generating the solution, they will give, okay, I want these enabled, I want this enabled, I want this enabled. Okay, if they don't give, just go with the defaults. Okay, just go with the get head, and rest of the things you can leave default as well. So cache HTTP methods, okay, I have selected get head, it's giving me get head. Now cache based on selected request headers. Do you want to based on cache get cache head? I don't want that. You want object caching. Okay, do you want to cache your object? Yes, I want to cache my object. That's why I'm using CDN. Okay, so minimum TTL, how much time will it spend, before refreshing? It can be 0. Maximum can be, so these are all seconds. Okay, this is 1 day, this is I think 1 week or so, not sure. So do you want to forward cookies? Maybe you can, maybe you can't. Okay, maybe you don't want to. Okay, whitelist, all, whatever it is. Do you want query string forwarding? You can have all, nothing. Smooth streaming, do you want to enable smooth streaming? Okay, so smooth streaming, no, if your region is configured to use Microsoft IS for smooth streaming, but I haven't done that, so I'm clicking yes. So restrict viewer access, I don't want to restrict viewers access. Compress objects automatically, yes, I want that. That will save my data. Do you want a lambda function? Just forget about it, don't think about it. Price class, so you can have these three price classes. Okay, so this depends on where your users are. Maybe all your users are in US, Canada, and Europe, right? So you can only use this. This will be a bit cheaper. Maybe your users are in US, Canada, Europe, Asia, Middle East, and Africa, right? This one just skips South America, right? So it will be a bit expensive than this one, but yeah, still cheaper than. But if you are a global company, you have users all over the world, okay, use all edge locations. Do you want to do a web application firewall? Just leave it as it is. Do you want to use a SSL certificate? Yes, I want to use a SSL certificate because I have selected HTTPS above. Okay, so whenever a website like this one or is on HTTPS, you are presented with a certificate. This is their certificate. This is Amazon certificate. Similarly, you will get one for this CDN, and it will be free for you. Okay, so then comes the supported HTTP version. Okay, what version of HTTP? So whenever you write a website, there is HTTP in the start, right? So it also has a couple of versions: 1.0, 1.1, 1.2. So what all you want to support? I want to support all of these. Yeah. So default root object. Do you want to specify a default root object? Maybe I want to, like my default root object is this AWS IAM lab, right? So let me select that. I will put this only. And do you want to enable logging or not? I'm not going to use IPv6. Yeah, distribution state enabled, and just click on create distribution. Okay. So it was not liking all the content that I have put in there, spaces and all. So as soon as this will be created, you will get a status that it's completed. So let me go in there and just explain to you what all different stuff is there. Okay, this one we already discussed. Origin group is already there. So let's go to behaviors. So I have two behaviors here. Like I am allowing what? HTTP to HTTPS redirect. So if I go to HTTP, it will automatically take me to HTTPS. See, I got an HTTPS. I typed in HTTP apart from access denied because it's still creating. I got HTTPS here, right? So that's good. Now let's see what happens if we click here, change behavior, right? So if I click on edit and I enable both HTTP and HTTPS, click on yes, edit. Yeah, so I didn't get promoted to HTTPS in this case. See, you're saying not secure, but earlier it was just pushing me to HTTPS automatically, right? And I can go to HTTPS as well. So both are working, both secure and non-secure version. Okay, it's giving access denied because it's not created fully. So that's why it's giving access denied, but I am getting both HTTP and HTTPS. Now let's edit and just block HTTP, just HTTPS only. Okay. Now, when I try to do without HTTPS, see what happens. 403. I'm getting an error because it's just not allowed. But yes, if I do HTTPS, I'll get same access denied because the object is creating right now. So yes, so right now I'm able to use this on HTTPS only. So if a user comes and types HTTP only, he will get 403 error denied. So this is the difference between having HTTPS only, HTTP to HTTPS, and HTTP and HTTPS. So best thing is redirecting HTTP to HTTPS. That way, your user is always on secure traffic. You won't lose users because they typed in wrong URL, like they typed in HTTP, and you are automatically moving them over to HTTPS. All right. So you can also create custom error pages. Maybe you want to return, say, let's create a custom. So for what error code you want to create a custom page. So like right now what we were getting 403, right? So if I want to create a 403 page, I can create it. If I want to create a 400 bad request, I can create it. So for all these errors, you can have different error pages, right? So we don't want that. Do you want to enable any restrictions, right? So geo restriction, if you want to edit it, you want to enable. So maybe for certain countries, like say US has sanctions on a lot of countries, for example Russia, right? You don't want your content to be visible in Russia. Okay. Yeah. So this country will not be able to access your content. Any user coming from this country won't be able to access your content. Maybe US has sanction against Iran, right? So you can select Iran, add it here. They won't be able to access your content. So that way you are compliant to whatever rules your country is setting, and you can just block access to those geolocations, right? You can also create invalidation. So maybe you want to remove some object, right? So you can create invalidation objects. So for whatever object you create an invalidation rule for, it gets removed from CloudFront. Okay, it won't be copied from your S3 bucket to the CloudFront. Okay, so this is also an option. Maybe there are 10 objects in your S3 bucket, and you want validation. You want only 8 of those to be available on CloudFront. 2 of those you don't want on CloudFront. You can do that. Okay, so by default, when you are selecting an origin, when you are selecting S3 bucket, everything from that S3 bucket will be moved to CloudFront. So all 216 locations will have copy of your S3 data. But yes, if you want few objects not to be copied over there, you can definitely do that with invalidation options. Then you got tags. So you can create a lot of tags. It's just to identify your different buckets. Let's see if it has created by now. It's still in progress. It's going to take a lot of time. So the next topic, there is a topic called S3 Glacier. So we did discuss that yesterday. So Glacier essentially is a archival storage, right? So what do you mean by archival? Maybe some data that you don't need instantly. Whenever you want it, you are okay with longer retrieval time. With S3, you have instant access, right? So when you are on S3, you want to download this, you just click on download, right? And it gets downloaded for you. Okay, instantly you get the download. But say there are some data files that you are okay to just wait a few minutes for them to get downloaded to your system. Maybe you have an archival log file. So whenever someone comes for audit of your organization, maybe they want to see last 1 year of data or last 5 years of data. So you can have that data in S3, but keeping it in regular bucket is going to cost more. So you can save some money by putting it in S3, because S3 Glacier. So S3 Glacier is like 1/10 or 1/100 the cost of some of the S3 charges. So that way you save a lot of money. And whenever you are going for audit, it's not a very urgent case, because you will get a prior notice from your audit company. Okay, we are coming on for audit on this date. Please have all documents ready. So you get a plenty of time to put in a request, and maximum time that it takes for your data to be retrieved in is a couple of hours, maybe 3 hours or more. Maximum that I've seen is around 6 hours, but 6 hours is still good, because you are getting for audit or something like that, you will be getting advance notice maybe 1 or 2 days prior. So you can have your data ready. And once you have put in a request and your data is ready, the transfer is instant. Once it's ready, it's just as fast as clicking this download button and downloading that file. But yeah, to activate this download button very fast, you need to put in a request to AWS. Okay, this is my data, I want this. And AWS will say, okay, hold on, let me find it. I have put it in an archive. It will be restored for you. But yeah, hold on. So it will take some time, maybe a couple of hours. And if you are really lucky, less than an hour or even. But yeah, if it's your bad day, then up to 6 hours. Okay. So how you go about using it? So you go to services, click on S3 Glacier. Okay, so you click on S3 Glacier. This is where you will be taken to, right? So you have to just click on create vault. As soon as you click on create vault, so where in which region you want your create vault. So my current region is Northern Virginia. It's showing me here, and I want to put my vault's name. So my AWS, okay. Next step. So do you want event notification so that whenever your data is ready or something, you get an email? Okay, I want that. Okay, and I want to create a new SNS topic. Okay, perfect. What would be the topic name? Okay, topic name will be my AWS class Glacier. Okay, all right. Now what would be the display name? I can go with the same one. Archival job complete. Okay, I want that. I want inventory retrieval job complete. Okay, don't worry. Yes, I want a notification for both of those. And I click on submit. As soon as I click on submit, I'm given a vault. Okay, this is my vault. Okay, so I have my vault ready with me. You can lock it, you can have permissions and everything. So let's go over these details and then put data in it. Okay, so first is region, on what time it was created, time and date. What is Amazon resource number? So ARN is something that Amazon gives to identify each and every resource. So each and everything that you create on AWS, be it S3 bucket, be it object in S3 bucket, or be it a vault, or maybe a server, maybe a storage, everything has a unique ARN number, right? So ARN number is ARN colon AWS, name of the product, the region it is in, its serial number, okay, its location, vaults, and name of the object. Okay, so how it is? First word is always ARN, second word is always AWS, third word is the name of the product that you're using, fourth word is the region you are in, next is the unique ID that you have, your account number, and then vaults slash AWS vault. That should be the actual location of that. So every object that you create, maybe if you look at S3, right? So even if you look at this also has a ARN number associated with it, right? ARN, AWS, name of the product, so in this case there is no region. Why there is no region? Because CloudFront is all over the world. You have selected all the edge locations, so that's why it doesn't have a region. It is global. So then your account number and then actual name of the product that you're using. So it's a distribution and its name is this, right? So similarly for S3 buckets as well. So if I go to S3 real quick, S3 buckets also have a ARN. Yeah, copy bucket ARN, right? So if I copy it and just paste it here, yeah, so this is ARN, AWS, S3. Again, this is global. This is not limited to just my account because this bucket is unique in the world. Then I have my actual bucket. Okay, so they keep changing these locations of like where you can find ARN and stuff like that. So yeah, you have to be very proficient in using your account. Okay, so this is your ARN. So variables, yeah. This is distribution Glacier. So this is your Glacier. Then I click on notifications. So yes, I have enabled notifications for both my retrieval job as well as inventory job. Okay. Do I want to set permissions? Okay, I don't want to set permissions right now because I am the only user and I want access to it. Okay, then you can have a vault lock. So vault lock is something that you can enforce compliance controls. Okay, so nobody should be able to download it, nobody should be able to upload it, or somebody should be able to upload it. You can all create all those policies. And tags is just again for identification purposes. So if you go to settings, so you can set your retrieval. So free tier only you can set because we don't want charges. So retrieval with free tier that exceeds the free tier will not be accepted. So that way you are not charged anywhere. So max retrieval rate, okay, how many GB you want. So maybe you want 100 GB. So if you want 100 GB per hour, you are going to be charged $20. So this is for retrieval, not for storage. So when you are retrieving it, this is what you are going to be cost. And for free tier only, it will be first come first serve basis, and you can have a provisioned capacity. So that way you can have each capacity unit. So more capacity you have, the faster will be your retrieval. So right now I'm just using one capacity unit. It is available with free tier. So that's it. But if you decide to have additional capacity, you want a faster retrieval, maybe some vault is very critical for you, you can have multiple of, but each of that retrieval capacity increase will cost you $100. Okay, so you have to be very careful with this, because this will instantly charge you $100. Yeah, so always stay in limits of free tier. And yeah, so let me put an object. So objects for Glacier are essentially taken from your S3 bucket. So if I click on upload, if I click on add files, okay, maybe I want to save this file, open. Okay, so I click on next, the permissions will be default, and I want to put it in Glacier. So as soon as I click in Glacier, so replication rule enabled for this bucket, the object status operator won't replicate if you need to replication. So whenever you're putting in Glacier, you won't be able to replicate it. What do you mean? So if I have a global replication enabled for my bucket, like I enabled yesterday, wherein one bucket was being replicated to another bucket in another region. If I have enabled it on this bucket, when I store into Glacier, it won't be, because Glacier is only in one region, is for deep archival storage. So it won't be. So it's giving me a warning, right? So I can have encryption. Okay, I want encryption. Then I click on next and upload. So as soon as I click upload, right? So this will be uploaded. It will show me here, but you see the storage class, right? So now the storage class is Glacier. Okay, and see, you cannot download or make it public. You cannot edit any property or permission. So once you have committed something in Glacier, right, you cannot directly download it, right? So if you want to download it, you have to request this object from AWS. Okay, so how you go about? So if I come back here, right, refresh. Okay, so right now there is nothing, because it will take some time for the object to show here, because I have just committed it. So it takes time to just poll its inventory. Okay, somebody has uploaded it, so it will be eventually uploaded. It's not a priority thing. It will get there, but it will take some time, right? So it takes a lot of time for it to start showing here. And if you want to download it, you have to just put in a request. And once you put in a request, it will take some time, and then you will get that object back, right? So whenever you want to download it, you have to put in a request. So now say you want to put in a request for this. So you have to click on restore. So as soon as you click on restore, this is the way it restores. So number of days the restored copy is available. Do you want to keep it permanently? Do you want the restored copy for 1 day? So let's say I click for 1 day. Now there are 3 restored tiers. Okay, one is bulk retrieval, another one is standard retrieval, third one is expedited retrieval, right? So for expedited retrieval, I get it in 1 to 5 minutes, but I will be charged $100 for it. Okay, so for standard retrieval, I won't be charged anything. Bulk retrieval, if you want to download a huge amounts of capacity, right? So huge amount of capacity, like you have 100,000 GB plus of files. So then you go for bulk retrieval. So right now I'm just going for standard retrieval, and if I click on restore, it will take some time. So as soon as it will be available, I'll get a notification on my email, right? But now it will take like 1 to 5 hours. Let's keep it, and it will be retrieved. So I have put in a retrieval request for this one. So whenever it will be there, it will just start showing the object here with storage class standard, and I'll be able to download it like other objects. Okay, but right now I cannot download it because it's still in, because see, the restoration is in progress. Once it has been restored from the Glacier, I'll be able to just download it. So today we studied both AWS CDN, that is called CloudFront. Okay, so let me go to the actual CloudFront page. So this is the official AWS page. So it also mentions you can transfer 50 dB of data, 2 million HTTP requests to AWS CloudFront with your free tier. Okay, that's just good to know. You're not going to reach that limit if you're using it for your own, but yeah, that's the limit. So AWS CloudFront is Amazon's distribution network. So what I mean by distribution network, say you have some object in your S3 bucket, right? So as soon as you want your users to access it, so if it's only in your S3 bucket, it will be slower for some users because S3 bucket can only be in one region, or you can create multi-region bucket. And multi-region bucket, you have to pay, like if you want all the regions, you have to pay 24 times over. So AWS came up with CloudFront. It's like a mini data center that is closer to the user. Okay, so your S3 bucket gets copied to those locations. So you have 216 locations. So now you have 216 copies of your S3 bucket that are way closer to user. Okay, so what are the benefits of it being closer to user? It will be faster, right? So when your data is way closer to the user, okay, they will experience low latency, high data transfer speeds. Okay, you can have it for S3 for static content, EC2 for dynamic content. We'll study EC2 as well in future, but for now, just concentrate on S3. So if I have an object in S3, I can distribute it over CloudFront. Okay, so whenever you publish an object on CloudFront, you get a URL like this, test1765 CloudFront.net. It will be some random URL given by CloudFront, and your content will be served over secure connection, HTTPS, and you will get certificate for it. That usually costs $300. Since Amazon is bundling this service, so it's usually free. So how you go about creating AWS CloudFront? So if I go to CloudFront here, you just click on distributions, create distribution, get started, name of the origin from where you want to pull it, any path you want to pull, you want to restrict packet access or not. Okay, create identity if you want any identity. I don't want to. You can have origin headers. You can have all these options. So these options I explained in detail in my video. You can view that later, right? And then you just click on create distribution. Once you have created distribution, it will start showing up in the distribution section like this. Today we will be studying two more AWS storage products. So if you actually look at storage, we are done with S3, we are done with S3 Glacier, we are done with CloudFront, and today we are going to be studying Storage Gateway as well as AWS Snowball. These are the two important storage services. So you can say that like Snowball is under migration and transfer, but yeah, it's essentially a storage service. Okay, and even CloudFront, you would say, okay, this is not under storage, it's under networking, but yes, at the end of the day, it's a storage service. So they are organized around here in somewhat organized manner, or maybe what AWS seems fit, but yeah, some services can be under different names, different categories. So let's go to AWS Storage Gateway first. AWS Storage Gateway. So whenever you come to AWS Storage Gateway, you will be presented with a page like this. Okay, so what's on this page is a small introduction. So say you have a data center, right? So you have a big data center, all your data is in there, and now you want to store all that data in cloud to AWS. Now, definitely you need to transfer that much data to AWS. You need to have a constant connection for your data. So you can have two kinds of connections, right? One connection is over the internet. Okay, it's a normal internet connection. Maybe you get a 100 Mbps, 1 gig, or a 10 gig connection. And if you think about it, 10 gig connection gives you around 1.2 GB per second of data, right? So say your data requirements are way more than that. You want even more. You can keep scaling your internet connection, but it's going to cost you a lot because a 1 gig connection on an enterprise level will cost you thousands of dollars. So AWS came up with a solution wherein you can connect AWS storage infrastructure with your current IT infrastructure in a very elegant manner. So what they did, they partnered with lot of providers out there, lot of internet providers to provide storage specific, high speed, low latency networks to AWS customers, right? So this is not something you can do practical on. I mean, for setting up your own storage gateway, you need to have your own data center, right? So this is actually a data center product, but yes, you should know like what it does and where it is used. So whenever you're giving an exam for AWS Solution Architect Associate, they will not ask you for setting up a AWS storage gateway. For that matter, they don't ask you to set up anything, but yes, you should know if any case arrive, you should know how to work around, and you should know what that service actually does. So being a solution architect is more about knowing what a particular service does rather than knowing how to do it, right? How you can easily figure out with a couple of Google searches, just fiddling around your console, you can easily figure that out, right? But knowing which service to use, which will be most efficient, which will be best for that particular use case, is more important, right? So unless until you know that, you'll have to keep on looking at each and every AWS service unless and until you find a right match. Okay, so if you look at AWS Storage Gateway, so this is the official AWS Amazon Storage Gateway page. So what they do, it's a hybrid storage solution. Okay, hybrid means half on your data center, half on cloud, right? So you have your presence on premise as well as cloud. So you have access to both of those. So say there are certain services that are running on premise that want really low latency data access. You can give them storage from on premise. Maybe they want to expand their storage more. Maybe, okay, no worries. You can connect to the cloud. You can even connect your tape backups to the cloud. Okay, reducing on-premise storage with cloud-backed file shares. So that way your cloud-backed file shares can really, so you don't have to go out and purchase new storage, because your on-premise storage can now be infinitely expanded with the help of cloud, right? So you can have a tape gateway, file gateway, volume gateway. So what is the difference between a tape gateway, file gateway, volume gateway? All three are types of storage gateways, right? So tape gateway, so you might have heard, like whenever you're doing archival or storing huge amounts of data for backup purposes, many big companies they store it on storage tapes. So what does a storage tape looks like? Storage tape. Okay. So if you look at the storage tape, if you look at it, 6.25 TB of compressed data and 2.5 TB of normal data, right? So this is 5 pack. Okay, so it will be around 10, 12.5 TB of data, right, in $140. So if you want to purchase a hard drive, okay, in $140, you will maybe get 2 TB of data, right? And here you're getting 10 TB of data. So it's way cheap, right? So it's very cheap going like on storage. So even HP makes one. But these are used for only backup purposes or storage, long-term storage. So what is the reason they are used for that only? Because to store data in a serial manner, it's really easy. You just keep on writing on it. Okay, so some of you might remember back in the day we used to have Walkmans, right? So Walkmans used to have a small cassette. So if you want to listen to the first song, then the second song, then the third song, no problem, it will do that just fine. But say you want to skip a couple of songs, so you have to fast forward the whole tape, you have to spin the whole tape. That used to take a lot of time. So that is the same case with these storage tapes. So say you want to write data serially, no worries. But if you want to have random access to your data, you want to be able to read your data at any point in time, you will get a larger latency. But yes, if you are storing for audit purposes or maybe backup purposes, couple of minutes to reach to your data is fine then. But yes, for a real-time application, for maybe a web server, you cannot have this type of storage, right? So that is the actual usage of tape-based store, right? Then you get your file gateway. The file gateway essentially connects to S3, right? So tape gateway connects to Glacier. File gateway is similar to S3. So you can have file gateway. So in S3, what you store? All the files in your buckets, right? So say you have a similar kind of requirement wherein you need on-premise as well as cloud storage. So in that case, you will be suggesting file gateway. Then you can use volume gateway. So volume gateway is like getting hard drives from cloud. So maybe you have some kind of SAN system or NAS system, right? So NAS is like network access storage. So you have a lot of storage available over network and you want a similar capability. So AWS similar capability is EBS. So you can have EFS as well as EBS available to your customers over the internet via volume gateway. So these are the three type of storage gateway that the AWS provides. You can read more about them. It is more of a theoretical thing because you cannot really do practicals on this on your own. Reason being because you need an actual data center to set up a storage gateway. So you should know what it does. So essentially you have to read this page only. aws.amazon.com/storage gateway. So if you read this page, you know pretty much that is there for AWS for setting up AWS storage gateway, right? You should know the pricing, you should know what are the different things. So this is the pricing, right? So if you go at pricing, this is the pricing. Okay. So file gateway, this is volume gateway pricing, this is tape gateway pricing. Okay, this is data transfer between the different regions, or what you call it, from on-prem to cloud. Okay, so this is your pricing calculator. You can put data, everything. It will give you a cost, right? So you should know what pricing you are going to get, right? How much it's going to cost you, okay? And you should know how to set it up. But you cannot really set up on your own because you need a data center, because this is a physical thing, right? Just read about it. You'll get questions around it. Okay, say I'll give you an example question, right? So in exam, you're presented with a solution, right? Scenario, right? So in exam, you'll get a question like, okay, a company wants to expand their storage solution. They already have a huge amount of AWS workloads running. Now they want their current storage solution to be able to talk to AWS storage, and they want it to be integrated into their main IT infrastructure. So what are the steps that you will suggest to set it up? So the simple answer is set up a storage gateway. Analyze what kind of storage they are looking. Are they looking for file storage, tape storage, or volume storage? Similarly, suggest tape gateway, file gateway, or volume gateway. Okay. So next great product. I really love this product. I mean, it's a genius product from Amazon actually. So it's called AWS Snowball. Okay. So what does AWS Snowball does? So it's almost like AWS Storage Gateway, but not quite like it. So I like to call it Amazon shipping in reverse, right? So why is that? Say you want to move 1 petabyte of data, like 100,000 terabytes or 100,000 GB of data into cloud. Okay. Now, when you want to do that, there are a couple of challenges. First is your internet bandwidth, how much bandwidth you can get, right? So let's go with the bandwidth calculator. Bandwidth data transfer calculator. Okay, let's go with this one. So upload time calculator. So say I have, let me go to terabyte, and I have 1,000 terabytes of data, and I am going with 100 gigabits per second. It's a really fast connection. Okay, so with a 100 gigabit connection, I will need 2 hours, 30 minutes, and 20 seconds to transfer that data. But a 100 gigabit connection, to set it up, first it will take a lot of time. A company has to provide me all that cable and everything. They have to do that, right? And then I have to talk to AWS to provide me 100 gigabit connection. So mostly the companies end up getting 10 gig, see, 22 hours, and even 1 gig connection usually. So usually the internet connections are around 1 gig. So with 1 gig connection, you will take around 9 days, 6 or 30 minutes and 20 seconds. So it's close to 9.5 days, right? It's more than 9.5 days. So to transfer 100 terabytes of data, if you don't want to incur astronomical costs, right, you will have to wait for 10 days. Now that's an issue because you want the data right there. So essentially with AWS Snowball, what you can do, you can just ask AWS to send a guy with a small device. Okay. So if you look at AWS Snowball, okay, so they will come with that device like this, right? So they will come with the device like this, right? So this device will have 42 or 100 terabytes of storage. So you can go for 100 terabytes of storage in every one of these. So say you want to transfer 1,000 terabytes of data. You just need 10 of these. Just order those. Expedited shipping, Amazon will come to your doorstep with 10 of these. Just hook them up to your server wherever your storage is. Transfer everything onto here. Close it again and just send it back to Amazon. As soon as it reaches Amazon, they will hook it up to their data center and just unload your data into their data center, right? So let's think about it. Okay, so initially I'm getting 9 days with 1 gigabit connection. Say I want to transfer 1,000 terabytes of data. Not an unusual case. It happens. It's 92 days. Maybe on 10 gigabit connection, which is most popular for an internet connection, I'll take 9 days. Yeah. Now, what I do, I instead go with Snowball. Okay, let's go with Snowball. One day for Snowball to arrive at your doorstep. One day to say transfer data and pack it up again, and one day for it to reach Amazon. So within 3 days, you have transferred all your data back to Amazon, right? So initially I was taking 9.5 days. Now I'm taking just 3 days, maybe a couple of more hours. So I have now an advantage to ship data real fast to Amazon without overutilizing my internet bandwidth. Okay. So say if I am utilizing my internet bandwidth, AWS upload will take all the bandwidth that is out there, and my other user will be left hungry for bandwidth because they won't be able to use the internet while I am uploading huge amounts of data for 9.5 days. So yeah, usability is there. Second thing, with AWS Snowball, you can physically migrate petabyte scales of data, right? So if you go to features, fast data transfer, okay, right? Encryption is there, so it's not like even if it gets stolen while in shipping, don't worry about it. It's encrypted. It's rugged and portable. Okay, it's tamper resistant. You cannot really tamper with it. End-to-end tracking, every kind of tracking that Amazon provides will be applicable here as well. It's secure, erasure. Okay, has been verified. As soon as the data transfer is verified, Amazon will clean the Snowball device, right? They will erase it, delete everything that was there for whenever they are sending it to new customer. It's programmable. You can, interact with it via API, via CLI, right? And there are some specifications. So if you want to look at specifications, here are the specifications. So it's 47 pounds. These are its, and this is how it looks like. RJ45, SFP plus fiber connection, multiple of these. So 16 core CPU, 16 gigs of RAM, and so on. And you can just transfer your data and ship it to AWS. Okay. And with AWS Snowball, right? So this is AWS Snowball, wherein you get a small device, okay, small device like this, shipped to you, in which you can transfer all your data and ship it to AWS. And as soon as it reaches Amazon's data center, they'll plug it in their own data center and just unload your data there. So this is nice for smaller amounts of data. Maybe you want to go crazy and transfer more amounts of data. So Amazon will literally send a truck to you, right, to move exabyte scale of data to cloud in weeks. Okay, so exabyte is 100,000 petabytes, right? 100,000 petabytes. So this is right now 1,000 terabytes. If I add one more, this is 10 petabyte. If I add one more, this is 100 petabyte. If I add one more, this is 1,000 petabytes, right? So if I calculate, it will take me 9 to 59 days over a 10-bit connection. Just not possible. Even if I get a 100-bit connection, it will still take me more than close to 3 years to just transfer my data. But with AWS Snowmobile, they will come with a truck full of AWS Snowball devices, right? Just plug them right into my data center. And as soon as they have plugged it into my data center, I'll be able to start transferring my data. And within a couple of weeks, that's something that was going to take me close to 3 years on a 100 gigabit connection. And that connection can break anytime, it can go down and everything. I can do that same within a couple of weeks, maybe 2, 3, or maybe 5 weeks. Right? So 3 years worth of work, you can actually do it in a month or so, right? So Snowmobile is like big daddy of data transfer, right? So this is smaller, the Snowmobile device. Okay, this is the Snowball device. This is our Snowmobile. Okay, so the question can come like, okay, I want to move 100 petabytes of storage. What should I use? The answer is for 100 petabyte of data, right? You want to use something like Snowmobile. You want to transfer 100 terabytes of data. You have to use Snowball, right? So this is how it works. So this is the pricing page for snowball, right? So you can see cost around 0.03 per GB. So data transfer into S3 is 100% free, right? So it will cost you a service fee of $200 for a 50 TB transfer, 250 for snowball 80 TB per snowball 80 TB, right? So if you want to transfer 800 terabytes of data, you will just pay $2,500. They will send you 10 of these, and first 10 days you'll be free. Then every extra day it's gonna cost you $15 more. Okay, and data transfer into AWS will be completely free. But yes, if you are transferring it out of S3, yeah, these are the values. Okay, and shipping is calculated based on how you are going to ship. And if you lose one of those devices, you will have to pay $7,500. Yeah. So this is how the pricing for Snowball works. Snowmobile, it comes with its own special pricing based on the customer, because if you are moving that much data into AWS, you definitely have special pricing for you, right? These are retail pricings. Okay, whatever pricings are these are all retail pricings. But definitely, if you are running your enterprise workload on AWS, so you will definitely preferred pricing. So if you are a huge company, they usually end up signing up some kind of a document with AWS wherein they promise, okay, we are going to run our services in AWS for 2 years, or maybe 3 years, or 4 years, or 5 years, whatever it is, or we are going to give you a minimum of this much business. You give us special pricing, so AWS discounts some pricing for them. Yeah, but these are just a retail pricings, whatever you saw. Now the next service that I'm going to look at is EFS. So Amazon Elastic File System. This is something that we are going to be actually doing with EC2. Okay, so it comes under storage, I agree to it, but it will be more understood when we do it with EC2, because right now I can create file system, but I won't be able to use it because it gets used alongside EC2, right? Just wanted to put it out there. So this will be, I think, second or third class of AWS in terms of compute in EC2 when we will be doing, right? So yeah, this will be like we'll be doing this then, right? Understood? Because it works with any number of EC2 instances. So it only works with EC2. If you don't know how to use EC2, there is no point in learning Amazon Elastic File System, right? So we'll do this with that. And similar is the case with FSX. So it's fully managed third-party systems. So it also works with some kind of server technology you have to have there. So you can have FSX for Windows file server for Lustre. So these are the two file systems that it provides. But yes, you will need either a Linux server or a Windows server to actually use this. So this we will do when we study the compute options. All right. So let's go to AWS backup then. So let's look at this. AWS backup centrally manages and automates backup around AWS services. Okay. So whatever backup you want to do, right? So it will be one of these backups, right? Either it will be EBS, RDS, DynamoDB, EFS, warm backup, cold backup, and storage gateway snapshot. So all these, when we will study these, you don't have to worry about this. When we will study these, I'm going to definitely discuss how the backup happens there, how we will back up EBS, how we will back up RDS, how we will back up DynamoDB, right? So right now, if I tell you, okay, this is how I back up a EBS snapshot, you don't know what a EBS snapshot is like. I haven't taught you that. Maybe you know, and some of you might not know because it's your first time. Somebody has already read and they have worked on it. They might know. So for them, it might be easy. Yeah, but I am going to skip over this because unless and until I teach you what is EBS snapshot, okay, I cannot really teach you what AWS backup actually does, right? So you have to learn these before you can start learning about AWS backup. Okay, so these couple of services, right? EFS, FSX will come with EC2, and this will come with different services. It will keep coming up as we go through compute, as we go through database, as we go through storage, as we go through network. So AWS backup will keep coming up, but yeah, these will be done with EC2 when we do EC2. Yeah, so I did forget to tell you about these reports, right? So what are these reports? So CloudFront cache statistics. So CloudFront is essentially a copy service, right? So you have your data at one place, it copies it all over the world. So what it does, all over the world, like in all the data centers it has, it maintains the local copies. So these are all the data centers the CloudFront exists in. It maintains local copies there, right? So it means local caches there, right? So when it's maintaining local caches there, so it will keep telling you what is the cache statistics, right? So you got how many requests? Say you got 18 requests, yeah, or 256 requests in total. Okay, how many of them were hits? Hits means you didn't have to come to back to that S3 bucket where you were picking that data up. Okay, not as an example, but good to know all this what it does actually. Okay, so and errors are it didn't found anything there. So a user was trying to search something and it didn't found it anywhere. Okay, these are errors. And what are the misses? Misses are when it didn't have data in CloudFront and it had to come back to the S3 bucket, look for data and then copy it over. Okay, so higher the hit value, lower will be the miss value, and lower the hit value, higher will be the miss value. So more you miss, right, lower hits you get, and more you hit, lower misses you get, right? So it's like that. And it shows how much data you have transferred, right? And so these are status codes, these are get percentage, how many of the requests were get and that did not finish downloading. So you can have all this like detail that is there. You can in previous 60 days, hourly, you can just view all the reports that you want. Okay. So if you want to look at the performance of CloudFront, you come in reports and analytics. All right. So I think that would be it for today's class. Okay. All right. Thank you guys. Bye-bye.
Jan Bass Training. Learn and grow.